concentrated on engineering students, and we thought, okay, maybe let's see what is with students, and we realized that this science textbook which each and every class or every board has, it's not updated in the sense they have not known what is happening in the current generation of what's happening now. So we wanted students at this age to know more about space, and this was our first summer space camp which we did for school students, and we had around 150 students coming from all over India. And
Space Week started, and the World Space Week Association of Board of Directors start every year with a specific theme, so that the participants of this celebration will base their events on this theme. This year's theme is Space Unites the World. So it's one of the incredible themes so far. So before going on the theme, I would like to play a video. So this video is a TV series, one of the famous TV series in 1980 called Cosmos by Carl Sagan. So this video is based on
this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, everyone who ever was, lived in their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on the mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lone speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
1980. In 1982, he completed his master's degree in applied electronics and went on to pursue his PhD from Anna University. In 1982, he joined ISRO and he was the spacecraft operations manager for Indian remote sensing satellite, and then he was promoted to the deputy project director of INSAT 2C, 2D and GSAT, etc. In the year 2011, he became the project director of Indian National Satellite System, and then on 1st April 2015, he became the maintenance director of ISAC, and he is under his supervision developed 30 spacecrafts in which there are 6 student satellites, and it was completed in a record month of 40 months. I would just like to brief on his awards during his journey. He was listed among the 100 global thinkers of 2014, and he topped the list of innovators. He also writes regular columns in a Tamil daily known as Dina Thanti, and his works are even mentioned in the 10 science textbook of Tamil Nadu. And beginning 2004, he has served as program director for Chandryaan 1, 2, and also the Mars orbiter mission, which brought India in the list of top 4 nations like NASA. Then we have Russian Space Agency, then Federal Space Agency, and also the European Space Agency. His awards include the Rajyotsav Prashasti Award from the government of Karnataka in 2008, and then some of his international awards include Lawrence for Team Achievement Chandryaan 1. It was awarded by the International Academy of Astronautics by Beijing, China in the year 2013. And then he received an award from ISRO Outstanding Achievement Award in the year 2014. And finally, he received the Padma Shri Award in 2016 by the Government of India, which is one of the highest civilian awards in our country. He has almost received 75 awards till date, and the list just goes on. Sir, we welcome you and we are thankful that you two are there. Welcome, sir.
Yeah, it's more like classroom. We don't need any other support for the class. Correct? Hear me. Okay, now. Yeah, thank you very much for providing the opportunity. Nice evening. Shridhara Murthi also around here. It's really, really good thing. And we try it's really fun place. I worked in ISRO for 36 years. First ever celebration and first ever event I'm being in front of World Space Week is today. Anyway, sir, besides that, it's really a coincidence. We could go around and other things supporting for World Space Week. We are fantastic. Anyway, today I thought challenges and opportunities space technology. I can see from the investors and alone getting and by doing yes, I think how you can get the opportunities and we'll take opportunities, how the challenges and process. These are two ways. Give challenge, how to bring opportunity challenge. Opportunities given, how to make use of opportunities, another challenge. There is the two ways. The whole two ways will go that way. That is how to grab an opportunity challenge. And given the opportunity, how to make use of it is also another challenge. Okay, how to go about this is by putting the things together. And just before going my lecture, just I want you to read about our mind is something which introduces your thing. Now, can you guess what this word is? Everyone has to guess, isn't it? Even though 50% is no, you are able to guess it. Are you able to guess it?
Yes, sir.
Perfectly, no?
Yes, sir.
Can you spell the word? Can you spell it? Huh? You are able to?
Yes, sir.
I think you are able to read it as a wonders of
Perfect.
perfect. That's perfect. Everything is perfect. One part. Can you understand what is this now?
Yes, sir.
Huh? 50% no doesn't mean you know 100%. Perfect?
Yes, sir.
That is perfect, no? Our mind tells something one way, but really you look at here, there is a 50-50 chances are there. Okay? Looking back here, right? This can be O or Q. Perfect? That can be B or E or F. Things goes like that. Q or O. Okay? Irrespective of that, we every one of us, almost every one of us, keep it as got it, no? So this is why I'm telling is sometimes we think knowing something, remaining is right. Okay? I think taking this, I think it's going to go ahead. Similarly, the topic what I plan to talk probably would have assumed something. Probably. This you grab the letter. Like how you assume 50% of the letters assume something. Similarly, looking at my topic, you would have assumed something else. Okay? Need not be the same. That's what it is. Let us see how it is. Now just giving a history of Indian space program, its evolution, starting from 60s and 70s, experimental way, and 80s, experimental to operational. Slowly came some 4 satellites in the picture. But though it operational, predominantly some of the satellites were done outside. Inside 3-4 satellites can go outside. We got into operational. Remote sensing, we have done one thing together. But 90s, we graduated into nearly communication, remote sensing, and operational system. Okay. And 2000, nearly, now you got through here, nearly 50 satellites are operational. Okay. Approximately 300 plus transponders, multiple sensors in various spatial spectral resolutions. And over and above that, first time in the Indian history of space program, we could go to the moon, we could go to the Mars, and we are able to make the satellites sit here. Launch vehicle also graduated that way. Now having all these things, what is moving ahead? The Indian space program point of view, but here, now the national demands are coming in a big way. Possibly we may get to the international opportunities also may come to us. All put together, there is an opportunity coming here. But how to make this an opportunity challenges? Let us see that way. But in my own way, not be what you are doing. On my own way. Now, can you guess who is this man? Other than Shridhara Murthi. Can you guess? Huh? Yeah, just I'm putting the things in perspective. That is what is happening is, when I joined, I was like that. Okay? That's the reason perfectly I'm coming just today here, how I changed it, how ISRO changed it. That is the whole story of it. Okay, just 3 months into ISRO. 3 months into ISRO. I gave a place here. That time satellites were launched and we were asked to look at the satellites and see, operate, something happens. Like it. Then the idea came, place idea came. We can't make a satellite in a software form. Okay. And you look at here, satellite is sitting in a 800 kilometer, 2,000 kilometer around the moon, around the Mars. But give the signals, and finally it comes to the producer. We see in the space. Correct? And looking at that, we are operating the satellite. But now, without even the satellite putting there, you try to mimic the satellite how it behaves there in the software form. And you are able to do that with the system. We are able to understand much better. So we will get ready for when really the problem comes, we are able to get ready. So is it possible to get that? This crazy idea again. And Professor Rao was director that time. And he, I think, our boss was sitting around him. And accordingly, we are given Professor Rao told yes, but he gave just 3 months to do his role. If you are ready to do this on your own shoulder, take the responsibility to do it. That's what he did. And this, of course, then I learned, though the idea came very fast, but to realize that we should go to 5 years. Okay. That made me to understand what is the whole system of the satellite is. The satellite consists of military, telecommand, power, thermal, structural systems, and the communication systems. And this whole system has to work in a scenario around the earth, around the moon, and accordingly that the gravity comes into the picture, how the thermal environment with space coming into the picture, how the shadow eclipse are coming into the picture. This is all the interface you have to understand. Go putting into software now, it calls for very little. And now down the line look at here, today even for the going for moon or Mars, before operating the satellites, we are using the satellites simulator to really all our command sequences, what to do with satellite, we tested this, then only we are able to do that. So that we are able to make almost a fault-free operation. Successfully when we are doing which, definitely this plays a major role in our overall system is concerned. Then we started into 3 months it is. Now, can you imagine what it is? What I break itself here? There is a fight between, okay, Sumo fighter. See, a allowance is given. Okay, it's a 1 boy, 2 boys it can fight. That's Sumo fighter. But still, who will succeed? Huh? Okay, now slowly you will be guessing. You don't want to give the thing to the Sumo fighter. But here the thing is, there is other side. There is a flow of is kept there. These people have to go and take that. That is the challenge. Behind him it is kept there. These people have to go and take it. That is the challenge. Okay. Who will succeed? Now you look at here. This problem has come 10 years into this. I am trying to correlate. Okay. You can understand what is the Sumo fighter. Who is this people? You can understand. Now you look at what happened. Scenario. Can you see the scenario? Can you understand?
Yes, sir.
What about the other boy? He vanished the sea. He vanished from the sea. That's what you guess. But it is not the case. Because overcoming a big obstacle was for some other ingenuity. Okay? He will be big in his muscle. This man may not be big in his muscles, but he is something big in some other form. What is that? Now you can understand. Slightly. He may look like big. Looking at that location. If you look at the big picture, it is no longer big. It is no longer big if you look at the big picture. Correct? That means in this big picture, how that small boy can make the player around this. Let us assume both of them given a running race. Who will win? Small boy. Correct? No? Race is just to change the game. Okay? Basically, you have to go and take a flower back other side. Doesn't mean I have to fight with him alone. His strength we cannot do, but I have another strength. Taking the bigger picture. Okay? This boy can run. Correct now? This is the thing. Now this is not a philosophy. This is how we are applying it here, satellite itself. That's what I'm going to do here. Now take the larger picture, how to do it. That means you have bigger ground available, this fellow can go around and take it. Perfect? Now, same thing happening. There is a satellite which we launched. Okay? And the first GSLV flight has gone, the GSLV satellite happened to mission directly there. The satellite has gone up. Some other problem, even on the problem is the satellite, its major power is solar panel. Solar panel has to rotate on its own axis. Okay? It is geostationary satellite. Earth is moving around, and along with the Earth, the same similar 36 kilometer, almost looking for a stationary, just keep this also going around, going along with the Earth. That means it is like the sun is changing its illumination. Same thing will happen to the solar panel. That means now Earth is rotating 360 degree, solar panel also has rotated 360 degree once in a day to maintain the power is available. But unfortunately, like the Sumo fighter, there is one particular angle when it comes, panel not able to rotate. Got it now? panel not able to rotate that particular place. But now you cannot go and correct it. Okay, how to correct it here? The same analogy came here. Now it is not able to, it comes here, it comes up to here, beyond it not able to move. There is no meter sitting there. But luckily we have another 359-degree location is free for it. Free of that it can go. Correct, no? Same thing we operated there. That means the solar panel can go that way, then reverse the gear, okay, you come back here. When you coming back, you can come in a faster rate, it will come. Within 8 minutes you can come. The battery power is available for 72 minutes. That's typically maximum 72 minutes eclipse depends on both. So remaining 8 minutes you come back here, then start rotating. Okay? This is how the satellite was, we are able to circle the satellite for lot of time. Okay? Just I'm telling an obstacle can believe an obstacle, provided but you can change the game, provided you can do it like differently. Just like trying to do that things. This is another 15 years in ISRO. I am running through my life. Okay, this is another scenario. Can you see what? Can you imagine what is picture here? Blind. She was not blind all along. She was not blind all along. Okay. She, when she born, brought up schooling, college, even until going just a year before on this scenario, until she was okay. She could have a good job, everything is okay, fine. But one fine day, she lost the things. Okay. But it's a big loss, isn't it? Big loss, correct, no? Now you look back, whatever I told, it's a big loss, a loss. She has everything. Okay, she has full education here, and she is a beautiful family. Everything is perfect. Okay, everything is fine. But one day the two eyes have gone. So the two eyes have gone. It may look like it's a baby, but she got only two eyes have gone. Can you rephrase the word? Only two eyes have gone. Remaining everything is okay. So with that she was able to go. So that's only what that stick helps some other way. But otherwise everything is perfectly okay. But for the two eyes have gone. Correct, no? Similar thing happened on one of our satellite. Okay, another satellite. This is again beautiful satellite. Okay. First when I told the satellites we used to procure from other side for our own thing. But this first our satellite called ISAC 2E. And this covers this much area. Okay. All our today's capability, other things started coming from this satellite. Now it is going even not only for our own India, even for beyond the Interns hired 10 transponders of $10 million per year. Like the two satellite was covering. It was functioning okay. Equating the gear. Okay. First year everything was fine. Okay. And just end of the year, like eyes, we have the sensors. Exactly, we have the sensor that look at the earth. Okay. And if it deviates from the earth, the sensor will tell yes you are deviating from the earth. So automatically on what computer will sense it. The sensor sensing the course corrects using the reaction beam and the orientation is okay. Such that the TV programs across this area, okay, across this area, okay, the TV programs are okay. Then this is how the satellite was designed. Then, as I told, first year, end of the first year, we have two sensors, like a two eyes, main and redundant system, main sensor type, okay. Then another 1 year, second sensor also. Okay. But satellite can live for another 13-14 years. It can live. But now you're looking at here, elsewhere we would have abandoned this satellite because without that it would not possible to maintain such an altitude. But now we thought, except to the sensor, everything is working fine. Whatever I told you, except that everything is working fine. Then why to abandon the satellite? Okay. Now we have whatever I told, same way. Looking at the problem, slightly differently. Looking at the problem itself, there is solution. Looking for a solution in the problem. That's what I'm trying to tell here. That means I told the sensors are working, your TV program will come out. No, just look at that same statement. If your satellite is deviating, sensor will sense. If you correct it, TV program will find. But sensor itself not working. Okay. Now the sensor. Now you do what happens? Sensor not working. Satellite deviates. What will happen? TV program will TV program will affect. But that means TV program affects means satellite is deviating. But okay, now you look at here. Previously, satellite controller sitting in MCF person, they were looking at the sensor parameter. The sensor parameter is not okay. The satellite is not correcting. They will try to correct it. Now forget sensor is not available with you. Okay, the whole thing is to make TV programs correct. Now why can't you bring all the TV program to here? You look, keep watching 24/7 TV program. Okay, got the point now? You watch TV program 24/7. If any one of the TV, for example, Delhi TV is okay, satellite per se is okay, but any one of this TV program is problem, satellite is getting moved this way. Program with this is problem, satellite is moving this way. Program is problem here, satellite moving this way. Like that, you can understand looking at the TV program how the satellite is moving. Possible, no? Now that same signal you slightly modify it how computer can understand and automate that way. Looking at the TV program to make the satellite alright, we have done it. In spite of the fact the two sensors which is what really required has to be corrected further. But this I am putting in a simpler way. And but putting all the things together to make it a ground computer understand and to operate the whole satellite. Yes, it's all meaningful. Okay, again you have to correct that so-called Tarker's profile you have to uplink there, so that as per the Tarker profile will go there. But that's another aspect. But one problem is without the sensor being on board working, trying looking at what it's supposed to do in the ground, and we can correct the ground computer is supposed to correct it and connect the ground computer to the onboard computer to make this work. So with this, the satellite worked for remaining 15 years but without any issue. Remaining 15 years. Okay, I don't think anywhere else anybody else would have done that. We have done this thing. That's it. But now these are all the story about the satellite what already gone. Now we look at the satellites. We are doing with the fresh some grace areas like here. Now system implementation ways we do. Why I'm telling is the satellite program per se has its own multiple things. Either to make the satellite, having done everything satellite, thinking that there also problem will come. You must have to understand accordingly come with your own way of dealing with that. Now this is another example. Okay. This again is also could have been a crazy idea that day. Okay. This is the technology innovation. Then Chairman ISRO, Dr. Shridhara May 12, 1999. May 12 of 1998 was Pokhran, our nuclear test was done. So that day, every year they celebrate that it came here. So he made a lot of presentation. Last of his video talked about a possible mission from ISRO for the moon. Okay. That time we had just only 2 such PSL launches. That time talking about. Okay. But still, this was a crazy idea. Talking about possibility of lunar mission going to the moon. He talks about somewhere 140 kg satellite going around the moon. Or 270 kg satellite can go and come back like that. Irrespective of all these things, just to do this, working out the mission objectives and payloads will take time. If all goes well, it's still about 1999. It could be a reality in 2008. It was told 2008, like that, 1999. Okay, that time we did have even just 2 PSL launches successful. With that, I think this was good there. But this idea, the crazy idea, how we made it as a reality, same 2008. Okay, so this is whatever he talked about, germinating an idea, just an idea here, whatever. But it calls for a systematically going through various forums to make sure that because money has to come. Okay. Idea is one thing, but to make the idea to really make it, it has to go through various forums, convince the various things, finally coming to the endorsement to the Space Commission, then announcement by Prime Minister, 15th August of 2003 happened. Okay. No announcement taking place, really actually budget and other thing point of view somewhere February, March of 2004 only we got approved. So first kick-off meeting of 2004, we told our launch would take place 30th September 2007 on record we told. Because 2008 we told, before 2008 we done it, 30th of 2007 is make like we decided, and and we went ahead there. But now, why to go to the moon? Okay, problem is before that so many people have gone to the moon. Why we have gone to the moon? Why we used to all sovereign case there. People even landed on the moon came back. What to do? Within ourselves, within the team, we discussed and we should have decisive answer for water on the moon. Because people told water on the moon is not there. Here again, just to see what I'm writing there. Water on the moon not there at all. But our question is, whether it is correct? Because we have not seen the whole moon. They have kept the samples from the selective places, came back to tell water is not on the moon. To tell even water is not there on the moon, you should go through the whole moon. Whole moon as we see. Then only is possible to tell water is not on the moon. Correct, no? So now, instead just going around the moon, carrying some number of remote sensing instruments, goes to go through the moon, around the moon. Now it is going to the pole to pole. Again, pole to pole, people have gone 67 times go to the moon. Just before Chandryaan, only one mission has gone around this polar mission. All were going, missions were like this. Okay? That's why we decided to go like this, carry this instrument, and when this goes around the moon, moon itself revolves 28 days under revolution. So all these instruments together enable to keep on scanning the whole moon. So that when this is sweeping on its own, this goes like this comes like this, put together when we are around a couple of months around the moon, we are able to see the whole moon. So with this all these instruments, we are able to see what are all the difference around the moon, including water is there or not. If water is not there everywhere, we will be able to tell decisively what is not around. Correct, no? Right. Now, at this point of time, we gave an opportunity, but that opportunity, this is what another opportunity I opportunity was given, that is for academic. Okay. Students from India come out with the announcement of opportunity for one additional science instrument for our overall science subject. Correct, no? One more science instrument that will come from India. Originally it came like announcement of opportunity for like that. Unfortunately, except one idea somewhere in Belgaum, one school student asked for, is it possible to do for life on the moon? Just an idea only, but not, we are looking for instrument. No instrument came from within India, but good number of instrument came from outside India. They were giving opportunity. That is another opportunity. We are offering opportunity for Indian students. Indian students didn't take that opportunity. Okay, but whereas very many people from outside the key. So now we are trying to see another opportunity from this opportunity. Okay, that comes like this. So while doing like that, two different calls came. Telephonic, those days telephones would play very good. No cell phone. Okay, and one call came from Dr. Kala Peter. Next day, Dr. Possibilities. Two different people from NASA, two different laboratories. They asked and they told, we have an instrument, both of them. We told only one instrument, both of them telling, I have an instrument for a water under the moon. He tells, I have an instrument, even beyond surface also I can see, subsurface also I can look for the moon. If water is there, we can look at that. Two different things came. And these two people are the people, they were originally also working in Apollo missions in their younger age. And they are beyond that, they are given opportunity. But they thought moon is a barren, they were given opportunity. But when looking for this, somehow I mentally felt, because I could read good number of their papers, why to go to the moon. An opportunity was given to us. We are looking for why to go to the moon. And these people are telling, pure science point of view, I go to the moon. She tells, moon, beyond science, resources also are possible to the moon. From the moon we can do. So, two different school of thoughts why to go to the moon. And two people leading two different teams. Somehow mentally, but we should carry both instruments. Okay, the story comes like this. Now, innovative thinking can be done by a team also. How would it happen? I'm trying to tell how it has happened. Now I called our team and told, now we are supposed to give one instrument only, but now somehow we accommodate both instruments. How to do it? We are discussing how to do both instruments we can have. Then people are talking about two instruments is very difficult. Because 10 kg only we can do. Two instrument putting is very difficult. How to accommodate? Even if it is as a team we do, politically it may not go through. Okay. Two instruments coming from ISRO here, NASA alone, the other European, Japanese, Bulgaria, many instruments many people offer. If you take two instruments, you cannot take both from same organization, that will come. So how to do it? Again, problem came. So then, again, one more question for you. This puzzle is, can you imagine what I'm trying to tell? 2 lines are there. Correct, no? 2 lines. I'm correlating our situation. Our situation is, we have offered only one instrument I can take. So many instruments have come. But now mentally we are prepared, you have taken 2 instruments you have taken. How to take? No. That means, between these 2 lines, okay, somehow I should make this line larger than this line without striking this line. You have to it. How to do? How can I do?
Extend
Huh?
it.
No, there are 2 different. One is demand, another is supply, nothing like that. So we are offering one instrument only I can carry, but we have to carry 2 instruments. I am correlating that way. That means this line is shorter, this line is longer. What I can take is only this, but what is supposed to take is this. How I make this longer than this?
Extend it.
Huh?
Measure it in other frame of reference, moving frame.
Not like that. You look at this.
Extend
I
it.
don't want to strike
Extend
this,
it.
but I can stretch this now. I can stretch this. Now you got the point now. That means now no longer we told we are carrying 1 instrument. We told we can carry 6-7 instruments. Okay? We are ready to carry 6-7 instruments. That's what we have done. What we have done is that we told we can ready to carry 6-7 instruments. Okay? And that with that thing we are able to carry 2 instruments also. That's how we brought in so many agencies under ISRO for Chandryaan. We brought in not 1 instrument originally told. We told we can carry another 6 more instruments apart from our own 6 instruments. I think unprecedented 12 instruments Chandryaan carried. It's because of this. To accommodate 2 of the vital instruments, which I felt that day they carried. Okay, and with this again we made a good project report of the whole satellite, redefined the whole satellite, engineering point of view, reconfigured everything like that, and presented to the community. It is a international forum, and everybody felt, I think this first time India is going for, they are able to tell decisively what is there on the moon or not. Okay, this question will be unambiguously answered. I think everybody got, and that's that. But unfortunately or fortunately, Dr. Kalam was there in the meeting. He was the president of India also. And his thing is, you are going all the way to the moon, just 100 kilometers around, you are going around. With all the instruments, everything is there, but you are falling short of 100 kilometers. Somehow you place the moon. This is another dimension. Okay? Now it calls for totally relook of the whole mission. Technically speaking, the amount of fuel, whatever you are going to carry, okay, you need, let us assume 1 kg of the system you want to carry, you have 50% of this fuel, you go to 100 km. From 100 km touchdown, you have to reduce the velocity, you want to touchdown there, you have to carry similar amount of fuel to touchdown. So that means you already accommodated so many instruments, but now you have to carry another fuel. That means you cannot carry the instruments. You got the point? That is the situation. Now we are coming back as a team that discussing. Originally we told 1 instrument, now we accommodated 6 instruments. We have gone, everybody appreciated. Now Kalam is telling, touch the moon is telling, touch the moon you have to carry so much of fuel. PSLV cannot do it. PSLV, either you have to shut down the payloads or forget about what Kalam told. One of the 2 only possible. Either you do that or do that. But now somehow we thought we should do both. That's the crazy. I'm telling you about how the crazy is coming there. Somehow how to go for the both together. Okay, you have to touch the moon also, but do not remove the payloads what you planned on. This is what together happen. So it calls for a lot of preparation. Engineering point of view, a lot of preparation. It's called systematically you have to look for that. Various things you looked at that. But now finally what is one system to orbit, another system to reach the moon. This is another thing. That means you make the whatever you planned originally carry, but another only tiny system. Touch the moon doesn't mean the whole satellite is touch. Okay, can carry a small system there. It can be thrown. It will go, if Newton's law will work in the moon also. It will touch the moon. Correct, no? So what Kalam told also we can do, but what originally accepted with the other instruments also we can do. I think this is the crux of the whole problem of the But that also it calls for a lot of duration, because for even touch that one small system has to go, that much weight to take also. The whole satellite configuration has to be redone in multiple ways, keeping the everything there. It launched with PSLV only, launch schedule remains same, budget remains same, additional instrument whatever you have taken, everything remains same. But it calls for lot of iterative thing on the satellite system configuration. I think that's what we have done. Finally, satellite configuration came like this. You look at here, all the instruments actually is unprecedented. 11 plus 1 60, actually 16 sensors additionally we carry the same satellite, and this is what Kalam asked for, that this will go on the top of the satellite. After reaching 100 kilometers, it will throw this out of the satellite, that will go and touch the moon. Okay. Remaining instrument keep working for the rest of the line. This is what we have done that. This is how the satellite is configured. And while doing even this here also, this instrument, whatever we thrown also, in that also we included 3 instruments. Okay. That also will tell about one more instrument also added, whether water is there on the moon or not. You tell that slightly different way. That means mass spectrometer. Whatever Nitya told about ocean layer, twin layer. Similar things. Idea is mass spectrometer. The mass spectrometer when it's falling from here to here, it will take around 27 to 30 minutes to fall. While falling, mass spectrometer will try to sniff the so-called tenuous atmosphere of the moon, because moon is not having atmosphere, but around the moon atmosphere also getting generated. This is what our hypothesis. There is when the gravity not being there, geometric field not there, the solar radiation impinges, that will generate some of the, like our water vapor coming. Okay, so low atomic system or something is there, that will keep coming up. When coming up, that will generate during the daytime of the moon, generate tenuous atmosphere. Now, mass spectrometer sniffs through that. If at all water is there, water vapor should be there. If water is not there, water vapor will be there. Okay. It's also trying to look for a possibility of water in the scenario. So, but while building all these things, it's not to be free of cost. That cost for a 30 kg that instrument. It costs for total relook the whole satellite in various ways. Each way requirement, I'm not remembering that. Including each day you have to launch, including that also dictates. That's why initially I told September 2007, we made it to October 2000, September 2007 to 2008 launch when we changed this, because of one of the reasons is this. And many other things also you have done. Okay, many other engineering things also you have done, including this. Because this will ensure that the size of the battery can reduce it smaller. Okay, that is basically look at here. Once in 14 years we have a configuration something like this. Basically, look at here, sun is there, the earth is there, the moon is going around. Okay, but this should keep changing, this depending upon inclination keep changing. But sometimes it will go above this variables like this. But majority of the time it will go like this. When you go like this, eclipse will be nearly 4 to 5 hours. 4 to 5 hours eclipse battery has been sized. But when we go here, almost eclipse is non-existing. The smaller batteries would have. Okay, that is it. Out of so many equations, that means our launch should take place slightly from other day. That's where we are at. So here I am trying to bring in the mission like space is something like it. You need support of top management. You need support of the team people. Team also you have support. You have to play around between these two. Okay. Do not leave behind any one of them. You have to get both, because changing the launch date is not in your management has support. Changing many other configuration management has support. All the things are pretty there. But even though support is there, management team is not supportive, you cannot win. Okay, you have to play on the board. I am trying to tell that the thing. That's the whole philosophy I am trying to capture here. Okay, how we selected each instrument, and each instrument getting also not easy. Okay, each one who will do what. Many things are supposed to do that when internet control documents do. These are all planning. This planning itself is taken so much of years. Okay, for the 5th year only real metal cutting started. Just what I am telling is planning in the spatial sense. You have a lot of your ideas may be okay, but you should be until last thing. You should until last detailed planning is called. Very detailed planning is called. Real metal cutting is the beginning. That is the last layer. Because unless if you make a mistake here, you will not get it. So you have to ensure everything you have foreseen, accordingly you have done that. That's what you have done here. And this is how the qualified coupler. Keeping the schedule to maintain safe, budget should be there. Is to communicate internally, externally, because various people are working. Okay, if you look at the west coast of the US, all the way to Japan, many people are working for Chandryaan. That will be 24/7. Some lab are working. You have to ensure everything. And how the instrument comes up, everything you have to work it out very well, very planned way. Such that electrical, mechanical, operational, all the things are okay. Fine, this comes. This is ordinarily how systematically you should approach what is concerned. And this mission also, as told, PSLV were doing one of the thing is PSLV to make that much thing. You have to PSLV puts an artificial like this only. From here, the fear whatever carried by in the launch in the Chandryaan will incrementally improve the orbit. While incrementally improving the orbit, we will calibrate the whole systems. Okay, whole systems of thrust there, gyro, everything. Then finally into the slot here. Such that moon during the launch could have been somewhere here. Okay, and it keeps coming around here. When it comes here, you go make an orbit like this and slowly come and capture. This is what we have done. This I am giving preemptive because almost similar thing is doing for Mars. Incremental effort. That's the reason I am trying to do it. And yes, I initially told. After reaching the thing, we have oriented here and thrown that, separated that and thrown that Mars, something called moon impact probe there. And then these three instruments also keep operating. One will keep taking the pictures closer and closer of the moon. Another one is altimeter, keep measuring the height, extremely height. Mass spectrometer, trying to see what is there in the moon's atmosphere. And first jackpot we got 71 kilometers becoming. They are being a peak here. They are getting a peak. Mass number of 18. 18 corresponds to H2O. Okay, this is showing here. Okay. Now as keep falling, you can keep falling. 37 kilometers, 38 kilometers. As keep falling, that we keep peak is keep giving. Okay, indicating yes, there is water molecules in the atmosphere. It should come from surface. The first signature. Okay. Originally, all these instruments we carried to decisively to tell what is not. Just you look at here. Okay. Decisively to tell what is not there. That's what argument we have to. Because everybody told what is not there, so we should not carry the instrument to the direct water. But the argument is to tell even what is not there, we should carry the instrument. Okay. That's the argument was good. Otherwise, all the scientists said, oh, water is not there. Why you are carrying the instrument with the water? But our argument was, yes, to tell even water is not there. Okay, whole moon water is not there. We should carry the instrument. If any one of the instrument, if all the instrument tells water is not there, we will able to tell that. We carried record number of 6 instruments to tell water on that. First instrument is telling yes, shown there. Then subsequent instrument you look at, as she told, yes, you look at the instrument for that. This is called the Chandryaan 2, Chandryaan another instrument. So this is basically slightly different technology. It is looking at the reflected sensor. Okay, whatever sensor comes here, reflected my light tells red or shirt is white, this is blue. We are able to tell the reflected light. Correct, na? Similarly, this is reflected light. That our what visible thing is 6 micron stops. Okay, it can go up to 0.6 micron. Our visible thing is 2 micron. So if it comes anywhere tips like this, that goes there is a water molecule away that place. Okay, these are various altitudes. These are all various places happening there. This is happening means this place is called something like this. So these are all the places water is there. This is what discovery came. This is a place where water is not there, but Armstrong landed. Happening today also. This other side of it. So this is how the water presence has been seen in that. Now 27-28 CMT so I am putting clubbing there. So this all, what all I told here, putting here, I think Shridhara Murthi also last told me, you write a book like that. I think you written a book. That book tells about all these stories together. And in 2009, discovery of water on the surface of the moon. Okay, the crazy idea of what Rangan told 1999. Okay, we may be able to launch a modest satellite, become a real satellite in 2008, and we'll be able to make a discovery of water on the moon, historical discovery. Okay, carrying too many instruments, and you're able to tell mechanism of what can be there, because we have a good number of machines. Not only that, 2010 Chandryaan 2 orbital system hardware is also we are ready. That's also happened. 2010 itself. Now why we are starting, we are asking. Okay. Now parallelly, though we are looking for a move, okay, parallelly elsewhere, people are going for a Mars, because moon nothing is there. Let us go to the Mars. People are starting going to the Mars. That's what happened there. So good number of missions have gone for the Mars. Okay, this is around the same time. Okay, but now our mission, good number of hardware is supposed to go for Chandryaan 2 also ready, 2010 itself. And but Mars, why they are even though they are making an attempt parallel entry to Mars, so 51 missions have gone to the Mars, only 21 were success. Okay, remaining good number of missions failed, various reasons. Just a putting the reason why it failed. Launch failure, route failure, going failure, very many failures happened. Okay, and now because of that, nations in Japan, Russia, many people were looking for around 2011 next opportunity. That means every 26 months you can go to the Mars. Opportunity comes up like 2013, 16, 18 missions already lined up. Which mission will go to 13, which mission will go to 16, 18. These are all lined up. Okay, and equal opportunity 16 is not that much attractive. But you look at here, this two here is not that much attractive. But only this and this are very attractive because of the real point of view. But people are looking for this opportunity for the Mars point. But whereas for us, we told 2010 itself, our hardware is almost ready. Because Chandryaan 2 originally meant for, we will be carrying, India will be launching with GSLV with orbiter like something like Chandryaan 1 orbit type of thing. But lander and rover will come from Russia. Because original Chandryaan mission, Russia was not part of it. Here, various reasons, Russia came into a partner for Chandryaan 2 with that game. But unfortunately, they failed in a mission in the Mars. Okay, Mars mission 2010, whatever they launched, they failed. 2018 in AV. So that mission failed. That mission failure, they told they want to reconfigure the whole of their mission, their portion of it in Chandryaan. Okay, that they had gotten the problem because our whatever we originally configured hardware is ready, and we are asking for a request to change. With this put together, we got to be a problem. Okay, whatever hardware ready cannot go into the revised configuration what Russia has proposed. So we are in a real situation. So this is the situation. You can understand now. Irrespective of the age group in the team, people are all feeling we have done everything, and all of a sudden it's coming like this. What to do? This is the situation because Mars, water we have seen. People are going to Mars. Now we have seen moon can be just slightly under perspective will be happening like this. But whereas this man jumps. Why? Yeah. Now basically the idea is keeping the same whatever Dr. Rangan told, keeping everything same, our team we told, instead of moon, let us move destination to Mars. Everything remains same. Okay, so all was reality will be a reality in 2013 and 14, 2011 we do. Because hardware is ready for Chandryaan 2. Idea is whatever hardware is ready for Chandryaan 2 can be targeted for moon. Whatever the moon we are targeted, same way is possible to do it. Only thing is destination is different. Okay, this is 30 years into. Again more waste area. And you're looking at here. At that time nothing was there in the presenting. But putting all the systems went for what we made for Chandryaan 2 with very minimal change, it's possible to make a mom. That's how we have done. So this is how mom mission is done. Very few, only if you payload at one of the antenna, this is different. Otherwise, all the systems are which are ready for Chandryaan 2 can be put here. Only configuration correction. Okay, and that's how we have gone. The only thing is, picture is you will see this picture for Chandryaan 1 going. Now this is for the Mars. Can you click for the hyperlink? Click it. Touch. Yeah. This will look like what Chandryaan 1 we have done. Okay. PSLV puts same PSLV puts it there, takes it. Up to here almost same. Okay. Only thing is there we give slightly more thrust, and that will take it. Yeah, that will take something like this. Okay. Now Sun being the center, Mars is going around the Sun, Earth also going around the Sun. Now this one also going around the Sun. So now everything is without any fear, with under the gravity of the Sun going around, such that you are keep watching the whole scenario, such that when it comes over here, you are able to rendezvous around the Mars. Now here what I am trying to do is, there was an opportunity about to miss from you for Chandryaan 2, but we have taken another opportunity of Mars, using what is existing with us. Okay, with that only we have done this. Yeah. This again, like a discovery of water on the moon. So 67 missions have gone to the moon. Everybody told what is not there, because they all looked at the place for what is not there. But we have seen the whole moon. We are able to see the discovery of water. Similarly, we are about to lose an opportunity of Chandryaan 2 hardware not able to fly that year. But we took another opportunity elsewhere available and made it. And that mission, as I told previously, not even a single country succeeded first attempt. Okay, earliest is fifth attempt, America succeeded. But India would succeed first attempt itself, because of the experience what we gained Chandryaan 1, and because of way in which whatever learned from whatever the way they paid, all put together, they able to do this. So opportunity and this some of the sciences whatever has come out of that outcome of Mylaswamy is coming here. And this again, this also made a how Mylaswamy, how we have done, that's also we were there. And that again made a history. You know that 2 rupees was in Aryabhat, 2000 has become our Mylaswamy. 2000 rupees vote came. We took that opportunity also. So we are in the part of 2000 rupees also. That's another challenging thing. Mars Atlas is our own Mars Atlas based Mylaswamy is now available. Now 33 years into ISRO, by the time I became director ISRO. Now you look at here, this time another opportunity comes in a big way. Here. So this is Vijnana Bhavan, the Prime Minister of India, bringing all the department heads together across India, trying to see what space can do for each one of the department. Okay. Beyond what was doing that time, he told, irrespective of all departments, education, agriculture, tourism, forestry, all the departments, try to see how space can help for you. I think you come to the idea like that. 2-day workshop was there. We put forward what is possible there, but we are helping what is the requirement versus being a gone through that. And that exploded into a big number of satellites. I think this is what I read here. So that exploded into, you look at here, before that, our launch typically every year not 3 to 4 satellites. Okay. You all look at here, all the figures also come directly. Not more than 3 to 4 satellites. Okay. So this is whatever this talk took place somewhere in September 7th September 2015. So that translated into huge number of satellites we have to make for our own requirements. Okay, that's how it happened there. So now you can look at here. This immediately 2015 onwards gear chart change. Okay. Now we have to launch, for example, 15 we launch 7 satellites, 16 we launch 13 satellites, 17 we launch 10 satellites. Like that it will come. So subsequently what is supposed to do? This is from the ISRO website itself we can look at here. These are all the satellites we launch for every year. Of course here the planning will come, here again will be going. That means typically every month one satellite launch is the must requirement for our own requirement. Okay. And once we do it here, and the life of the satellite also will go. So we have to replenishment of the satellite also will be done. So that means the number of satellites to be launched is keep growing in a big way. This is another opportunity, some other beyond Moon and Mars, what all we can do within India for our own purpose is happening with that. And this translates into, you can look at here. Say each satellite consists of so many systems. Okay. Now if you, as I told here, various systems are there. Now you put the numbers. Okay, every year how many of the units have to be realized. Okay, first half, second half, like that, putting it. That means every year so many, every 6 months I am putting it here. This many systems to be realized. These are big number. Okay. This number ISRO alone cannot. That's what I'm telling you. Okay. This is challenge for ISRO is ISRO alone cannot. So the opportunity has been handed over to somebody else. Okay. Somebody is ready to take the opportunity to do that for the various systems point of view. Why I'm telling this? Look at here. This is how we join all the people. So now you look at all the way manpower. Manpower point of view. ISRO's manpower is more or less stagnant. Okay. Only thing is people are retirement, people are putting back. So that not really replaced, but still the number. But number of missions is keep going on. Okay. That means there's a big mismatch. Okay. Mismatch to capture, definitely industry has to come into picture. Luckily here the model, what we have done MOM 5 door, there is a big concept change happened place within the center. How to make the satellite. Okay. Previously, what are I telling you, these systems, okay, these numbers were done by specific to that project. Okay. But now this change is changing. Chandryaan we made for that hardware we flown to Mars missions. Okay. Similarly, why can't irrespective of the mission, why can't we make standardized systems? That's why make standardized system and go like that. And similarly, in those systems are done more. We can do it vendor, getting out of the vendor we can do. Like that, so many standardizations we have done here. This offloads the activities of what we done within ISRO and go to outside. Even spacecraft, they have to harder spacecraft. We can make off-the-shelf spacecraft, also possible. Off-the-shelf spacecraft, also possible. That's also we are trying to show that. So all the things are putting together. Project was driving R&D previously within ISRO. Now productionization drives project, but R&D for technology. We do not club the satellite and R&D. R&D can go separately, but whereas standard systems can come here. So here we are trying to bring in. So when I'm satellite or something like this, say this is the satellite. Okay, this is satellite. Now these are all different payloads. Can come and sit on that, depending upon that. This is already we have done a couple of satellites right now, all the last 3 years. That is the reason we are able to produce so many things. So that means, irrespective of the payload, this will be done a priori. This comes and sits there. Okay. That is the concept we are trying. So putting this concept, I think we have international seminar in India space program, trends and opportunities for industry. This was given as a 2-day seminar was given. I think it's available. Wiki has done it. It's available on this page. And with this, we have done a good amount of thing. I think industry partners are brought into ISAC and given the seminar what they can do, like that. And good number of infrastructure facility also done within the ISAC campuses. Like what this entrepreneur lab like here. Here infrastructure is made available. People can come and work here. Something similar is happening within the space campus there. So like that, we have done a good amount of infrastructure building also there. So that means it's a correct opportunity for the people to enter and try to see not only to make the satellite, and why I feel good opportunity lies in this place. Okay, good opportunity lies in this place, but let us not worry about too much like a satellite about. You take anyone now. For example, I know there is only 1 or 2 countries all over the world with converters. Okay, IR or MDI 2 converters they are only buying, and the remaining people are buying from them. But why can't we make in ourselves here? So this something like that. So this itself is a good number, because space industry, it is to make the satellite, how much money you are spending, almost similar amount each one of the systems make also happen. I know the contract what we are doing to the people. The contract amount for this and the contract amount who gets money for the intelligent satellite, almost same. Money wise it is the same, almost money wise same. Because more market is sitting here, but this I think can be done much better way over the Indian industry. And beyond that you look at here, as on the 1st of January 2018, nano satellite is coming in a big way, and a good number of nano satellites, and it has gone. I think the numbers are going. I think these numbers will keep going up and up and up. And another thing is PSLV is one of the attractive launch vehicle partners today, worldwide. Not other people are offering this much. So these putting together, there is a good possibility even outside people coming and making the satellite here. So that making a satellite and exporting from there is all the issues, logistic other issues are there. So there is a good possibility, like whatever I told, good number of subsystems can be done within India. Okay. Similarly, good number of these nano satellites also can be done within India. That's also emerging. This is also possible, considering the PSLV being here, so that in and around this place you make the satellite and you are able to move that place. Also, logistically it's possible. So all the things putting together, I think today I can feel a good opportunity is existing. It all depends on how to take the opportunity. Why I go through this? These are all the stages previously gone through that. But today, these are all things available there. But still, things have been approached very systematic. Because the space system is something, it's unforgivable things. Because any mistake, whatever you cannot correct it very often. Though I'm telling about very macro level. Small, for example, Chandryaan 1 supposed to have surveyed for 2 years. It surveyed only 9 months because a good number of DCTs converters which you imported, which got very. Okay, that's one DCTs converter weightage good enough to spoil the whole mission. So the quality of the things are very, very important to be done. But now volume is coming up very bigly. Volume is coming okay, but any one of them take and keep doing able to do that. This is another initiative you have taken, it is Space Plus 50. Where you know that this 50 years of our UN was starting, that's happened this year. And our offer is something like this. This also probably can be taken by the team to get here. We are trying to train the 3 batches of people. Currently something going something like this. Slightly modified for first year. Second batch will remain same. So where 30 groups of people are being trained there. So here you look at here, the idea here is not to train outside country people to make the satellite. Actually the conscious idea is the new entrance to the space, but they will be knowing what is space. They will knowing about application, they will knowing about that. But going back, they will able to influence the team so that they will come out with the make the satellite. So I believe first set of satellites will be done within India. The idea that it is not that they will make the satellite. Okay, it is only to give them some sort of freebie. 2 engineers each country we are calling. 15 countries they will come. They have not made a satellite as of today. So only thing is idea is these teams whatever we are telling they will able to go back and influence them. There is a good possibility they will able to come here. That is another thing. That is one side volume of things to be done within India is huge. And beyond that, we are creating a market. This is only creating a market. ISRO is doing. So this will be, we expect internationally also, good number of people again will come back for India to make this happen. This is another opportunity to speak there. So now we have to see that how we can get along with this enthusiastic team available. How you can make use of this opportunity. Okay, how you can make use of opportunity such that you get along with them and be able to make a good impact in that. Because definitely ISRO on its own cannot. They're very much sure about that. But our own national needs alone also cannot be done. Now for example, manned mission law has come. It's very, very difficult. Resources can be shared for our own missions. So definitely, industry has to come into picture. Academia and industry can play a major role. And over and above that, number of other markets also coming there. And we are able to play a role and definitely plays a meaningful role as possible. Now, that is 30 satellites in 3 years, whatever I am running my life. So now 36 years into ISRO, this is my last day. My last day in ISRO. I am very, very just at the last moment, and you can see how my people gave me farewell after 36 years. Okay. So it's really a fruitful journey. I can see that it happened there. And now it is outside ISRO. 2 months outside ISRO. No longer ISRO, now I'm outside ISRO. So now also I'm continuing my journey. I think today I can tell you this is maybe last 2 months plus 50 days something like that. And in nearly 70 days I have almost touched 50 people, 50 such things I have seen there. Okay, and across India, even outside India also we are India. And it's a good fun as well as sharing my thing. And especially showing an opportunity waiting for you people. Okay. Not like the olden days how we have started our thing. In a PA industrial estate we joined our thing. But today I can tell you our laboratories are as good as anybody else in the world. Okay, I can definitely tell that. Our laboratories are as good as anybody else. And definitely we can do a very, very meaningful role for the national building, and as well as possibly we can be a contribution for the international station and also possibly do that. And this is what I am trying to, whatever I am telling, I think I keep telling to many people. Thank you very much for giving me an opportunity. Factor of survival is neither intelligent nor strength, but adaptability. That's what the whole story of it. It's not the big, not the pseudo fighter is winning, okay, in the tiny boy, but he's adapting to the boy who is adapting. Okay, that's what happening there. So this is true for individual, organization, and nation. Whoever does that, I think it's happening. Today it's happening. India is adapting. ISRO is adapting. Individuals also adapting as well as groups. Yeah.
So is there anyone with any questions? Okay.
Sir, can you tell us about the Chandryaan 2 mission?
Yeah, Chandryaan 2 mission now is slated. What happened? So after that, what is happening is the total thing, whatever we gone to Mars, one system is gone to Mars. Now the system has been reconfigured. System reconfigured is everything is by India. That we launch by GSLV. Then we should have orbiter, we should have a lander, then we should have a rover. This configuration is there. Now when we are doing for this configuration, then when we are doing our testing also some re-corrections have come. The mission scenery also accordingly got changed. Now you look at here the final stages of thing. Now the weight of the overall system also gone beyond what Mark 2 can carry. Just go for GSLV Mark 3. GSLV Mark 3 and Chandryaan 2 orbiter remains same. Orbiter whatever are tested remains same. Rover also remains also similar system. But you at the lander point of view, it calls first time we are doing. Originally it's supposed to be number of ships. So we are not even having the high rated thrusters going to start. They have nearly more than 110 thrusters were there, but we are not having. So with the 800 Newton thrusters, configuring 5 numbers of thrusters, we have configured it, and that test is going on. So I expect early 2019.
January 3rd.
Okay. The test is going on now. I think what is happening is still integration for the lander is still on the way. Okay. Some of these carbon altimeters coming on the way from only from yesterday only. So we have to bring in and testing other things also to be done. Okay. So this particular mission is concerned. The landing is the first time we are doing. It's not like an orbiter what we are doing. You can correct it now. Because this has land and landing is autonomous landing. Okay, towards that I think good number of simulations already in a place. And here we had made terrain something or lunar terrain. Last 2 years, a lot of tests also going on there. So that feedback correct comes to these systems and corrections are in place. So January 2019 also.
Sir, are there any upcoming missions for reducing the space debris? As this is going on for a long time in the news. Space debris.
This is two aspects. One is the future how to avoid. The future how to avoid is one is, for example, these all nano satellites come below 500 kilometers only. They are not supposed to. So that it takes natural decay for years to happen there. And similarly, all our geo missions. Anyhow, we have taken last. I think almost all our geo missions we have taken care, okay, which we launched from ISAC 2 onwards, where after end of the life, we have to supposed to, that fuel something is reserved. With that reserve, we are supposed to push it up. Okay, so that no active orbits is sitting there. Similarly, depaciation of the 4th stage. The launch vehicle also last is sitting there. That also depaciation we are doing it. So these are all things happening right now. Beyond that, what already accumulated, again two aspects. One aspect is, in spite of this debris, how that will not affect our active satellites. One aspect. So that for that we have the global monitoring system in place. So any one of the satellite of ours, every country doing it, is the danger of being hit by another object. we are maneuvering the satellite to avoid that. To avoid that, this is almost a daily activity happening in our side. Almost every month, 1 or 2 satellites we are maneuvering to avoid. Beyond that, how to remove the debris itself. That I think is an international effort. Because it is a huge effort how to bring it. Technologically, some of the things happening there, how to grab that and bring them. But effectively, how to somebody will tell it is a debris. Okay, somebody would not have declared some mission. We cannot tell it's a debris. So how to declare a debris? Even debris is told how to collect it. That's an international effort. That's discussions every 6 months when we are going, it's happening there. But that we have to see now how to already gone, how to remove. That's a big effort. But these are all the effects presently happening. How to our system not to get hit and not to make a debris in future.
So one more question, sir. Nowadays we are listening that reusable launch vehicles. So is there any near time soon when ISRO is going to use it? Like tests are going on, that's coming in the news. But the first official mission on a reusable launch vehicle, is it possible in the near future?
No, but I doubt to think the things how to do it. But what is happening is even the large scale mission like SpaceX, what they are doing itself. Okay, your economic viability is being questioned. Okay, stages reusability is different. Vehicle itself being reused is another thing. Where the shuttle almost has been grounded because you got the point now. So the missions have to be seen in an overall other economic perspective point. Otherwise, technically yes, technically we are able to go, we are able to keep moving. But putting a timetable and doing, I think we have to see.
Thank you, sir.
So NASA they sent a probe called Ulysses to the Sun in the 1990s. So when will ISRO begin?
Okay, we, for example, we have our mission, not to that level, but we have a mission for the, I think it's more like SOHO, whatever NASA is, then Aditya, that will happen 2020. Already planning is in place. Overall concept is to go with the mission India, not around the, not go to the exactly the sun point of view, but Lagrangian point between Earth and the sun, the Lagrangian point. Around that will go, not go around the planet, around the Lagrangian point will go. So that will be a perpetual. You can keep watching one side, always watching the sun. Okay, in any orbiting mission, we have the on and off condition, but you can watch that. So some 5 instruments we are carrying. Okay, basically it's called activity see that. So that is vision is called Aditya. Project is already done. We expect on 2022 that's right.
So another question. Will there be any manned missions?
Yeah, manned mission already implements just declared now. Manned mission, India's manned mission. Yeah, it is 75th independence year. 2022. We have the 3 crew from Indian side. It's already declared.
Sir, how can we become like will they become space scientists?
No, first is enthusiasm. Okay, I cannot claim we are always enthusiastic. We are not even knowing there is a place called ISRO when we are young age. Okay. And ISRO also was very tiny then. Both are both were there. But today both are awareness is good, and ISRO also fairly good place to that perfect. But now competition also very good. Okay, another aspect. So, but at this stage we are able to get IIST entrance. The chances are very bright. Okay, University of Space Science and Technology. So, you are able to get admission. Your chances are very bright because the people there they have to come out with 70%. They will attract. They will be given the position in place. That is one opportunity. Second, any bachelor's degree of completion every year or per year. That is another opportunity. Or else of course graduation, PhD is possible. Now beyond all these things, I guess your age, beyond ISRO, outside ISRO, you have a lot of opportunities. Now that's what I'm telling them. Say, so no longer you can rely on ISRO alone. You yourself can create this. That's possible. way in which it's coming, I think it's very much visible. Because Elon Musk is a good point. Not really how you become like me. How I can become like Elon Musk, you can think about that. Okay, that is possible. Like me coming is okay, but that also it's possible. Today, condition in India also that's possible. I think keep the enthusiasm body, keep watching what's happening. And that way.
Sir, last question. I just wanted to know, like, you said about Elon Musk, so I just wanted to know, if a company like SpaceX has to exist in India, what do you think that feasibility of that? I mean, for a guy like, say Ambani is coming and telling, okay, I'm going to start a SpaceX in India. What do you think that is going to happen? Like, since currently we don't have any.
The thing is today in India also cannot avoid that to come. Indian space policy also keep emerging how to enable the private entrepreneurs to be part and parcel of India's space industry. It's already in a place. And how you make use of that is a challenge.
Because we don't have a current, like, we don't have a proper policy on that, right?
No, that's what I'm doing. No. Say, I don't know whether you got my thing. No. When I showed like that, meaning that only. Government of India, Secretary Space, making a statement, 1999, mission is possible 2008, is the craziest idea. It happened, no? It happened. Finally, 2008 happened. So it all depends on same government of India. Same thing, it is possible. Okay, so whatever the policies you are talking about, the same policy, many things are happening there. So it all depends on how you make use of the existing scenario. I'm saying the whole of crux is that only. Okay, we cannot expect everything somebody will do. It all depends on how you make use of what's available. Got it, no? The whole essence of my talk is that only. Doesn't mean everything is made available to you. But whatever available to you, how you make use of it, that is the whole crux.
Thank you, sir, for answering all the questions. So we have, will be the last question.
So I just want to know about the procedure for selection of payload, or what factors you go for considering payload for sector.
No.
As a part of organization.
No. What is happening is there are two things. So one is our own missions like remote sensing, communication, other things. Target specifications are there. Okay, what spatial, what spectral resolution, what radiometric things called about. And the communication, what the coverage, what the ERP, all things are talked about. According to that is for operational communication and the remote sensing missions. Perfect. And then from there we may ask for that specification somebody private vendor to do like that. Things will come and go. That is one aspect. Another aspect is like what Chandryaan will do, where we ourselves, I told now, this is our remote sensing mission. Our idea is to go around the moon and do something like that. So now with this objective, several instruments we are given there. Now people considering this orbit, considering this objective, who can supplement and complement our overall mission objective, they can give the instrument. But there is a real estate constraint will be there. Mass will be this much, power can be this much, something like that. So engineering constraint is one, science aspects are one. These two put together, someone has to find proposal for what can be given, like what are other people like one, like that. So then among them, we have our own way of weightage. For example, 26 hour scale. So we go, we selected 6 or 7 we selected 26 scale. So we have to wait among them and select one. But criteria are already laid down. Yeah. One is overall objective is given for that science instrument. Another one is engineering satellites for remote sensing are this. Everything is specified there. Okay. But only thing is someone has to make the satellite. Okay. There is a possibility you would have given even drawings also you make. Okay. That's also given. That's also, for example, some of them is given there, some of the development orders is given there. Various aspects are there. And that way.
Thanks for coming. And there was after the Mangalyaan mission, relations was strengthened. There were a lot of reasons how India was Yeah, and I read somewhere in BBC or somebody was giving some of the reasons. They did a lot of indigenous technologies, some new processes they brought in, and they made changes in the vehicle. And one of the reasons also lesser cost for the scientists and all that. Okay. So of course this lesser cost for the scientists and workers were put as a first point. Okay. It's a question that is the government and ISRO is really taking care, because it is a world-class mission which has achieved world-class results, but as a government really taking care, are scientists and people who are working in ISRO on par with the world standards? Because they are on par with the world standards, but their care is it on par with the world?
Yeah, now the outcome is definitely on par with
Yes.
others. There is perfectly no doubt. So now what's happening is, now you ask me bluntly, salary wise, we cannot be on par with others. We cannot be. Okay, why I'm telling is, once you do that much salary, outcome will not be that much in India. I can tell you. Okay, but that is whatever we are getting in rupee, they are getting in terms of dollar. In terms of dollar, if you give that much rupee, I think that's not correct. That's not. But we have to compare within ourselves. Definitely within peers within India, reasonably well. Okay, even though we are government of India, definitely government of India takes care of us better than other cadres. That definitely is that. And now they are linking with whatever we launch. For example, we launched previous year 4, next year 6. That is linked. Accordingly, we are being given a percentage of coaching. We are being given now. So we are asking, we are giving. So that way, within India, definitely we have taken care. Okay, and that's good enough. My feeling is that's good enough. I think we cannot think too much on that. I think me and my colleagues are happy to be telling you.
Sir, as you already spoke on space debris, sir, so I have a doubt, sir. So basically, space debris is the waste, satellite parts dismantled in the space, sir. So we know it's even a small particle in space, it can damage a bigger machine. So if a satellite is it has come with the end of its lifespan, why do they dismantle it, sir? And it's
that is different. Nowadays, it happened. It has not happened quite some time. What happened quite some time. Now what is happening is, one of the reasons why previously happened is end of the mission. For example, your laptops, you are seeing lithium-ion cells getting burst. You are happening that now. That you violate the way in which operating, it can create a problem. So these are all the lessons in it. Today we are not doing. Today, end of the mission, as I told, either we switch off everything. Okay. Nowadays we are doing. Now I think second case, so that this will not generate debris today. That's already taken care. But now something already happened. That how to do only we are doing. Otherwise today we are taking care. Today we are pushing it up and switch off everything, or else bring it down, burn or bury. So once man dies, we are not giving him as it is now. Either bury him or burn him. Similarly, satellites are being done today, but it was not done unfortunately sometime back. Issue is that.
So basically, there will be a separate fuel allocated to that, and then
today we are doing it. It was not there originally. That is like a plastic now. Now you use of plastic. Now we are aware, but damage has happened. How to handle it?
Sir, I have another doubt. Sir, in the presentation, the route, the path of the Mylaswamy mission, sir. So it was shown first it will be sent to the orbit of the moon, and then it shifts its orbit to the Earth, and then it will.
No. What's happening is similar way. Okay. Around Earth only we are keep going. The last one you take it, and I told when the moon is coming here, when the moon is coming here, this comes like the record.
Yes, sir.
Same path we have taken the Mangalyaan, but now not going to the Mars. After that we are pushing it out. So it goes around the sun.
In our use the air thrusters, or how it will happen? We need fuel, or how is the mechanism?
No, it is only throwing only.
Okay.
From the last one portion you throw it. twice goes around. Then beyond, it's only because of gravity of the sun going around.
Like at that particular point, you have to
Go on, give it velocity. Such that it goes around like this. Somebody has grown Earth sometime. Somebody has grown Mars sometime. Something like that. We are growing Mangalyaan now.
Thank you all for the questions. Can we all take it offline also? Thank you very much. So, it's like, I just wanted to share my experiences. Like, I was doing all the activities that sir was doing, and we were like, I must have sir for, with us for our community. And then I asked sir, and he didn't, he just said, okay, I'm coming. So that is the day I was like, okay, sir, I can't express that. Like, he said, okay, for the first go, you were so, my whole team is so happy for that day. And I would like to call Sujay to present. Thank you so much for coming.
Oh, no.
Okay guys, let's take 2 minutes of break maybe if you want to go out and come. Alright, so the next stop. So the next
Get connected.
I would just introduce our beloved speaker today, Mr. Shridhara Murthi sir. Mr. Shridhara Murthi sir is serving as senior expert in the Office of Advisor to PM on Public Information, Infrastructure and Innovations in India. He is the leading expert in space commercialization and space policies, with his rich experience in Indian space program as key positions. He served as Managing Director of Antrix Corporation and also as Scientific Secretary of Indian Space Agency ISRO. He extensively contributed to technology transfer and space industry development programs in ISRO, and also served as a counselor at Embassy of India in Paris, promoting cooperation between space agencies industries from Europe, India's space establishments. Mr. Shridhara Murthi sir has rich experience in promoting international cooperations and peaceful use of outer space. He was elected as Vice President of International Astronautical Federation during 1998-2002, responsible for relations with international organizations. He represented India as a delegate to United Nations Committee on Peaceful Uses of Outer Space. He is a member of the Board of Directors of International Institute of Space Law (IISL) and a trustee of International Academy of Astronautics (IAA). He has been the recipient of Social Sciences Awards of International Academy of Astronautics in 2003. The Astronautical Society of India Award in Space Systems Management in 2004. The ISRO Merit Award in 2007 for commercialization, and the Lifetime Achievement Award from International Institute of Space Law in 2007. He has around 40 publications in national and international journals and is co-editor of the book Perspectives in Communications, published by World Scientific Publishing Company, Singapore. So I now would request Mr. Shridhara Murthi sir to just come on the dais.
Thank you. Initially, I want to spend a few minutes off the agenda. I am very glad to see all of you coming from various institutions, many in Bangalore and also a far-off place like Tanjore, Shastra University. As far as the inspiration is concerned, you had heard Dr. Annadurai sir, who had given you wonderful glimpses of his own life at ISRO, various stages, the challenges that were there, what was the kind of attitude, and how many achievements were accomplished and so on. It is quite late now. See, many of you will be wondering, how it can relate to you. Some of you are aerospace engineering students. Some of you are from the other branches of engineering. The basic question is how you can participate in the exciting activities relating to the space program or aerospace activities. This is the most important question that will be in your minds, how you can relate it to your own life. And particularly for aerospace students, many of you will be wondering what is going to be the future and how you can get into organization like ISRO. So how to take forward is the question that many of you may have. So probably, I would like to spend some time in interaction. So first I will go through today the topic. Of course, from the organizers, the topic chosen was not about a technical subject, but the space laws. So I will give a little perspective on space laws, because as engineers, knowledge about other fields is important. Particularly aerospace engineers study different disciplines. Aerospace engineering is a multidisciplinary field. You should be good at many disciplines. So, what a experience in space or interest in space or a study in field like aerospace engineering gives you is a perspective, a kind of capability in you. Whether you are going to actually work in ISRO or not is different. But a field like aerospace engineering, it is much more challenging to find a job for aerospace engineer than for an electrical engineer, electrical and electronics, or even for mechanical engineers. It is truth. So please face this truth. It should be grounded in you, which means that you should be prepared to work hard, and your ability to take up this field of engineering and then understand, and then that effort itself will give you a capability. You feel wanted in a spectrum of other industries. So a good student in aerospace engineering, I have seen always he is successful. Even if he is not going to work in ISRO, he is going to be successful because he gets a kind of capability, which is very important. And particularly for joining organizations like ISRO, it's not mainly aerospace engineering alone they see, because space requires good mechanical engineers like IT field, good electronics engineers. Most of the spacecraft today is the electronics controls, even chemical engineering in the field of propulsion. So space systems, they require expertise, domain expertise of every field of engineering, you name it. More than that, the systems like aircraft or spacecraft, which have to work in very special environment, they need even perspectives beyond these domains of engineering. They also need an understanding of management, how to deal with people, how to work in teams, how to create that kind of understanding. So this is what ISRO has shown us. What we can individually do is something, but in teams we can achieve much more. Very complicated tasks we can achieve if we learn how to work in teams. Nowadays, in many engineering colleges, this teamwork is possible because you have many activities which give you that experience. So you should learn how to work in teams. It is not necessarily always as a leader, but also you should learn how to become a good team member. Automatically you become a leader. So good management appreciation is another thing which is very important for you as engineers. Today, engineer's role is even beyond that. He should understand about the external environment, because you have opportunities which are not just limited to a particular locality, a particular country, a particular state. Your opportunities are now global because of the information leakage, information revolution, globalization process. So you have to attitudinally prepare for playing a role or seeking opportunities and being prepared to change yourself to adapt to the demands of a global. And my experience over the years, we had opportunity to work with the professionals from many countries being part of ISRO, and Indian minds are very, very good. We are very highly respected by our peers or contemporaries in other organizations all across the world. So we have that capability. Only thing is we need discipline, seriousness. My experience of present day students, last 5 years I have been associated with the students, and many of them I find that seriousness is lacking, because they don't believe there is a future. If they work hard, they can achieve that future. A little uncertainty is there. So because of that, somehow motivation is not there. That is creating lack of seriousness. But without putting serious effort into anything we do, it is very difficult to achieve higher and higher level of achievements. And this is what you individually have to see, that how you develop an attitude so that you can feel wanted by others. Normally, good student is always wanted by the organization, wanted by the society. So I think have hope, be positive. These things help a lot. Even when you have so many uncertainties, even today we can tell you that every day we face an environment which is uncertain. So we should learn to deal with this uncertain environment. This is not only for you, everybody at every level, they have to face this uncertainty. How you can develop an attitude to adjust to that and still you try to achieve something. That is very important. So the main message, if I take from the presentation what we have seen, is to see in every problem, every obstacle, there is a hidden opportunity. It is only the perspective with which, while ISRO had many failures, many setbacks, sometimes years of work going down the drain because of the failures. The kind of fortunately we had the leaders who told us that look back what went wrong, try to understand what went wrong and try to see how you can correct it. This kind of encouragement, this kind of attitude to understand what was the limitation and how we can overcome. So each problem was seen an opportunity to learn. So if this kind of attitude comes, I think you will make a tremendous progress in life. If not today, tomorrow opportunity knocks at your door. This is seen in case of many young people, students, and they are doing wonderfully well. Many of them. I have last week I had been at the Astronautical Congress in Bremen, Germany, and I met some of the Indian students and the people, the students who are studying in German universities. They are extremely well. The companies with which they are doing internship, they are extremely happy. They won't let them go. So all that kind of potential is there in each one of you, and of course it requires motivation and positive outlook and continuous effort to renew that. And that can be easily done if you create the network, create the teaming with your own friends or peers outside. This is very important. Then you can sustain your enthusiasm, motivation and positive outlook, and seeing every obstacle or problem as an opportunity. And certainly my own observation is, today you cannot plan for a particular, your future career for a particular organization, work in a particular organization. No, you should train yourself to be suitable for a range of organization, range of skills, range of opportunities. That is the best you can do. Always just don't get bogged down that I should work only in this particular organization, in this particular type of job. That will limit you. Even if you may get that, it will limit you. So you go beyond that attitude, prepare yourself for a range of skills, range of opportunities. That's why today we learn something about the various legal environment in space, because it gives you a broader perspective, and after that I want to spend some time actually interacting with you, addressing your questions rather than you see my giving a lecture to you, which is not necessary in my opinion. Many of you are much smarter than me, and certainly you know many things which I will be talking about. Okay, so the topic I have chosen is the loss of outer space. It's our experience, in cities today. Just imagine if there are no traffic rules, what will happen? Everybody will be obstructing the other and causing a lot of difficulty to the traffic. So the laws are very important to regulate the activities, to grow the activities, and space also. Which is this one. Okay. What is so special about space, and why a law, special law, a regime of law is necessary for space? Let us spend a few minutes on that. Space environment is very different as compared to environment on Earth. The thermal environment, vacuum, radiation, and so on. So you need systems which can work in that very challenging environment. So that is one thing. Space has been a challenging frontier. Okay, calling for the best of skills to design, make things work there, out there, in that harsh environment. And it also provides a kind of a vantage point, which means you can have a view of a very large area of Earth. You can connect to the whole world because you are at such height. At geostationary orbit, 40% of the Earth is seen from that height, 36,000 kilometers on the plane of equator. You imagine a circle, orbital circle, and any point you can see 40% of the Earth. So any 2 points which are even as apart as 8,000 kilometers or 6,000 kilometers can instantly be get connected. So that is the outreach, connectivity. So, and also you can observe from space today, 0.25 meters or 0.3 meters level of detail, what we call as resolution, size of each picture element on Earth, you can see from a height of 500 kilometers so from the orbit. That is the kind of capability it gives. So you can, without any obstruction, you can look at the Earth to a level of detail where 1 foot size of object you are able to resolve, spatial resolution of that orbit. And also you can gather more information by looking at objects on Earth in different spectral bands, in the optical band as well as in microwave like radars do, or even thermal bands. So you can derive a lot of information about objects on Earth. So space is a vantage point, and moreover, today anything which is moving on the Earth very frequently, you can every millisecond, in fact, you can update the position either on the surface or in the even atmosphere. You can keep tracking any object. This is the function of positioning satellites. So from space you are able to do and give this GPS signal which is converted into a position information in a way that is intelligible for each one of you. So this has revolutionized. Now today we have convergence of observations or mapping and this positioning information whereby we can track. So the information you derive from space is getting into big data today. What is big data? Big data is lot of data not only of particular field but different fields, socio-economic data, either tabular data, or it may be a structured data, it is a map information. All this can be combined and give a lot of information. Today, marketing activities take benefit of this, or navigation takes benefit of this. The banking sector takes benefit of this kind of ability to merge different types of data and generate information out of that. So it has become possible to predict using the data, past data. You understand, that is one thing, but also use it for prediction of future events, like in weather, what is going to happen. Lot of data has to be collected, analyzed, and this large amount of information today it is possible to process, today it is possible to store and transfer because of the improvements in information technologies. And space data is getting merged into that. This big data analytics, IT services and so on. So behavior of the people, buying behavior, preferences, even without their name knowing. With analytics, people are able to, they're just seeing from China, they are seeing, how inflation, or in country like Argentina, they are seeing how inflation is going, how they are looking at all these shops, malls, their purchase information, the prices of various commodities, it is gathered by Walmarts and this type of malls, and then it is all combined together and then analyzed, and then immediately they are able to know about something else. So one type of data is serving the other type. and there is a kind of convergence, combination of various technologies, combination of various data to generate information which is needed by different people in this society. So space has become a vantage point to provide some unique capabilities of positioning data, observational data, communications capability, connectivity, and so on. Okay? And particularly for broadcasting, there is no match with space. Even 1 lakh, 1 million, 100 million population, space can reach. Now, Stephen Hawking told this human civilization, it will not be sustaining on earth for a very long time. If you 1,000 years, maybe beyond 1,000 years, it is highly doubtful. There are so many risks. So it is necessary humankind has to venture into alternate habitats. So people are spending a lot of money, very crazy efforts to go to Mars. It is a cold desert, highly radiative, the sandstorms are horrible. I think whoever goes first, they have nothing but hell and misery there. It's not at all a habitable, very cold planet. But still, people are spending a lot of money and effort to get there, take up this challenge. And space also today has become very preferred medium for strategic uses to support the military with all its capabilities. Okay. So all these characteristics make space, there is different people have different interests, different countries have different interests in space. Space provides lot of scientific information, understanding, caters to that spirit of exploration. Space has become a driver for economic activities. We will see it, all the governments are spending something like $70 billion, $70 to $75 billion, all the countries' governments. Whereas the business, including this expenditure from governments, total is 330 billion. So something like 5 times what government is spending, there is the activity from commercial organizations. So as rightly pointed out, you should not only look for working with organizations like ISRO. Now if you join ISRO, it is so big. You may not have opportunities like what we had when we joined very early. So for you should look for companies which are still young, growing. So growth is one factor. Look at whether the organization is growing, whether it gives you potential to grow. That is very important. Don't go and join a stagnant organization where you have to fight with the existing people. It is much more difficult. So you look for alternates which will give you the same kind of satisfaction, challenge for you. Okay? So you can see the status, more than about close to 8,000 satellites were launched, and initially nearly 2/3 of the satellites were all military satellites. Most of them, Russians, when they were launching every week, the satellites themselves used to live for only 7 days, 1 month, like that. Very short lives. Today we have communication satellites with life of 16 years. So you have to build satellites which are very robust, very reliable. Okay. And space economy, government's expenditure, space percolating into our daily life, like in your mobiles, you can see Google Maps, lot of space data is already into that. And of course, scientific discoveries, the exoplanets, planetary systems going around the stars, these were not known earlier. Today, every month, every year, the number is going up. Sometime back it was 3,700. It keeps on growing. So when there is a star in a planetary system, there is a chance that there could be life there out there. There are conditions which may be favorable for life to exist, whatever form it is. Okay? And there has been continuous human presence in the space station. Now space station Freedom is there. China is planning another space station because the Freedom is going to, of course, going to end after some years. It has provided opportunity for people to continuously be in space, one batch after another batch. So people have also created records of staying in space more than 1 year and so on. So why separate law for space? Unlike on Earth, we have regimes. See, when the Europeans, Britishers, Spaniards, French, they went and explored unexplored territories. Wherever they went, there was they planted their flag and they said that this area is ours. So the whole America was, the Spanish people went and whole Latin America got generated. In US also. Present day US, the natives were all brutally killed and then it was occupied. That kind of a law still you have here the sovereign nations and so on. But in space, what happened? In the very early beginning, Russians and the then Soviet Union and Americans, they were competing. There was a military competition. They were racing to be superior, each one over the other. So, at that time, both of them wanted freedom to be able to see the other. So they established a kind of regime where space should be available for all, free for all. So in 1967, when United Nations initially, there was an ad hoc committee and subsequently a committee on peaceful uses of outer space was formed, and it was given the mandate of making treaties, the law, international law for outer space. At that time, space is recognized as a common territory, irrespective of the state of development, scientific development or economic development. Space should be available on a non-discriminatory basis, accessible to all. There should be freedom of access to space. Everyone should be able to use space. Of course, not interfering with the others' activities. So this is one of the basic tenets of law. Only we find, in the seabed, law of sea, treaty. There are regions which does not belong to any country, but there are some resources. So they created an agency so people can apply, go and explore. So you can go and mine the minerals under the sea, which is a common territory. So that space is also recognized as commons, global commons. Everybody can go provided you don't hurt others, you don't interfere with others, but irrespective of your economic or scientific development, social development, you can go and explore. And they also initially, when they made the law, they said space should be used for peaceful purposes, because otherwise there will be catastrophe. There are already problems on Earth. Space will add more problems. So they wanted there should be more cooperation and space should be used for peaceful purposes. So the Outer Space Treaty embeds all these principles and it is recognized as a Magna Carta. They also said that the space, in this space there should be prohibition of placement or use of nuclear weapons or weapons of mass destruction. They didn't talk about smaller weapons, but they said that the nuclear weapons should not be stationed in space. Space includes all the moon and all celestial bodies. Okay, that is the definition of space. And they also said those were the days, in the very early days, there was also to send people into space. Both the then Soviet Union and the America, they were competing with each other to send. Initially, Russia scored by first sending people humans into space, but subsequently US also followed, and then to score over the Soviets, they had the famous Apollo program for landing on the moon. So there is always possibility that these rockets can fail and re-enter and fall into territories of other countries. So they said that astronauts should be treated as envoys of mankind. They should be rescued and they should be returned to the countries they belong to. So treat them with honor, respect, rescue them and return to the countries. This is one of the, otherwise you land in another country, they may arrest and keep you. So that is not allowed as per the law that was agreed. And another thing they said, whether space activities are conducted by a government, a state, or by a private entity, the responsibility is that of the government. Responsibility, this is called principle of state responsibility. So even if a company does something and causes some damage and some compensation is to be paid, the government becomes responsible for it. Okay. So that is state responsibility. And they also said you send satellites into space from other countries, fine, but launching state is responsible. Launching state, they define a state which launches or procures launch, or the territory from which launch takes place. All this is included in definition of launching state. So the states which are launching, like India, they are in great risk, because if something happens, some damage is to be paid for, compensated, they also become responsible. That's why launches, government authorizations and such things are necessary. And of course they said, the treaty said there should be mutual cooperation, there should be opportunity given for developing countries, their interests are to be taken care, and so on. So based on the first treaty, more elaborate treaties or conventions they evolved. Okay. So these international treaties are signed or agreed to by many countries, so they have to follow this. Otherwise, if they don't follow, then there could be implications for those countries. So rescue and return was the first thing where they have elaborated how the rescue has to take place, what is the procedure and so on. So I am not going into this, you get a thread of that. And international liability. Basically there are two types of damages that can occur while on ground. You are preparing for a rocket, you are preparing a satellite, there could be a damage. If something happens, one space object hits another same space object or causes injury to people, so the launching state is liable to pay the damage. If it is on ground, it is absolute liability. If it happens in space or in air, suppose rocket launching hits a aircraft goes for a toss, then the compensation or liability will be based on the fault. You have to establish it is fault of the people who hit that has caused the damage. So it is fault based liability. On ground it is absolute liability. They don't see anything. If some damage is caused, launching state becomes responsible. This is the difference. So how to identify whose space object in space? So they brought in the concept of registration. In the registration, each country maintains, it has to inform the UN Secretary General and it has to maintain a register. If you register some space object as from your country, you have the jurisdiction and control over the object, and anything happens, you have identity. This is yours. Okay? That's why registration convention has come. Okay? Then finally the Moon Treaty. Moon Treaty became the most difficult. Although 1967 the first treaty was done, Moon Treaty even in 1980s, when for a long time it was negotiated, there was no agreement. Only finally some 4 countries signed and ratified. There are 2 stages in which international agreements are made. First stage is called signing and second stage is ratification. You go through the parliament of each country and get confirmation from the parliament to be abiding by the treaty's obligations. So that is called ratification. So Moon Treaty had least amount of support. All those people who had power to launch objects into moon or conduct lunar programs, they did not become signing treaty because the question was about use of resources on moon. Some resources could be used. This was a kind of surmise. Helium-3 is there, you can use it for, say, power generation. Or there could be other interesting minerals, titanium and so on. Nowadays, asteroids or planets or moons like Earth's moon, they are all interesting objects because possibility of mining some of the materials which have value, but it should be viable, economically viable. So there was a question, to whom benefit should go, how it should be done. So there were 2 schools. One said that anybody who has enterprise can go and have ability to mine. The other school was no, it belongs to everyone, so everyone has to get the benefit. So there was no agreement on this type of resources utilization in outer space. So Moon Treaty became a kind of an agreement which was not supported by many countries. Okay. And of course India signed the Moon Agreement but not ratified it. India signed it. We agree. The Moon Treaty said that whenever big people become ready for exploiting resources, there should be an international organization, like in Law of Sea Treaty. International organization that should manage exploitation of resources and all that. Interestingly, recently America, it passed a law saying that the private companies can go explore, mine, they can own that whatever they mine, and they can also transfer it. So this is what. But Outer Space Treaty said no part of space can be claimed by any country as their own sovereign territory, either by occupation or claims of sovereignty or any other means. Okay, so there cannot be just occupation and say that this belongs to America, this belongs to Russia and so on. That cannot be done in space. It belongs to everyone. You can go and work, establish stations, do some activities, all those things are allowed. And without getting interference. But you cannot claim ownership. So, for launch services particularly in our country, we need now a risk coverage, insurance, obligation to take insurance. Otherwise, today, somebody comes, asks us for launch, we are launching. And we are only telling if there is any damage compensation you have to pay, they say yes. We are not ensuring that they have capacity to pay. Only, I think, insurance is very important there. Some reforms have to happen because today we are launching many satellites. Although many of these are small satellites, but still risk is there. Whether small or big in space, the speeds are very high. Even a small object can cause damage as was being pointed out. Then in remote sensing, there was a declaration. Treaties was becoming very difficult to make because difference of opinion. UN works with consensus principle. All people should agree. Even if one doesn't agree, the agreement doesn't happen. So it was difficult. Then there was only kind of declarations. This is soft law, that it is not binding, but encourages everybody to follow some rule. Okay. So in remote sensing, the question is, somebody can observe my territory, they need permission. This was the argument of some countries. Second thing, when they observe and take data over my territory, they will sell to third party. So my sovereign rights over my territory and my resources is compromised because if somebody else is imaging and selling it to a third party, even without my getting. So some people wanted consent for imaging, and secondly, they wanted that whatever being imaged, they should get that. So this became a kind of a clash between different countries, and finally they agreed on for observing from space is a space activity. It is a space is nobody's territory, so anybody can observe. So no consent is required. So we can observe over Pakistan, can observe over India. It's only a question of capability. Who has better capability? And second thing, when you sense a country, then the sensed country should have right to receive raw data at least. Or if information is generated, that should also be made available without discrimination. You are giving to third party, then you should also give to the sensed state without discrimination at reasonable cost. Because developing countries said that they may then price it very high, unaffordable. So they added the terms at reasonable cost. The geostationary orbit is a preferred orbit for communication satellite. Over 400 satellites today is there. 360 degrees of this orbital arc, which is in the plane of equator. You know, spacecraft cannot be maneuvered like aircraft. It cannot go like this. It can only travel in elliptical path or a circular path in a plane. This plane should be passing through the center gravity of Earth. The plane could be inclined to equator, but it should be passing through the center of the Earth. By gravitational force it will be going. The sole thing which decides at what height a satellite moves is its speed. Or you specify a height or the shape of the arc, speed is determined. This is just physics, Kepler's laws. So, at geostationary orbit, the one period of rotation synchronizes with the rotation of the Earth. So, the satellite always appears to be stationary, very advantageous for communications. You need not track the satellite to receive communication. So, this orbit is a preferred orbit, and there is clamor for the parking lots positioning the satellite. Although all this, will be moving in synchronism, since you can designate, the positions. Something over Nagpur, it is at 74 degrees east longitude. Something over Greenwich meridian, 0 degrees. Like that, all the satellites at some degrees it is parked, and they can't be too close because they can interfere with each other. So you cannot put too many satellites. You have to follow certain rules. These rules are made by International Telecommunications Union. And before you put any satellite, you cannot disturb an existing satellite. So the first come first served rule applies, has been applied earlier. So this causes problem. Now lot of our area is occupied by Chinese slots. Earlier it was Russian or Soviet slots. Many companies, because America and many European countries, they allow private companies to put into these slots. They coordinate as government entities but allow their private companies to put. So, lot of the slots are occupied. If somebody wants to put it, finds it very difficult. They have to go for highest level of technology. So, there is a problem. So, coordination is necessary. So, International Telecommunications Union does this job. All the governments participate in that. They formulate rules so that live and let live policy is adopted. But we have to be, you can see, this was some time back, and in the same slot, multiple satellites are put. Even in India, in the same slots we have put 3 or 4. It may not be in the same exact spot because there will be some separation. Here, this figure is small. So, in actual space, there will be some minimum space. And each satellite, anything which comes even closer by 10 kilometers, immediately they are alerted. From Hassan, we will send commands to see that, we maintain at least minimum separation. Okay, so space debris coming also we are always, or sometimes the solar radiation conditions change, solar maximum and so on. So these things cause disturbances. We have to protect the satellites from these things. So geostationary orbit is one important legal aspect. See, today we may have capacity. We have become rich. We have so many good companies, but we have no slots. You have not foreseen, and there is no real estate. You see how things dynamically change in the world and how we need to constantly think differently. So India becomes a rich country, the kind of problems are very different. The nuclear power sources. There are two types of power sources used in. One is radioisotope. Canadian soil. So it uses uranium 235. There is a fission reaction, controlled reaction of course, not reaching critical stage like in bomb, but here you have concerns over safety. So there was a declaration about what are the safety measures that should be adopted when you use nuclear power sources. What should be the limit? What kind of provisions you have to go through? Okay. And there was a lot of questions about space debris. It's constantly today, international community is working on the space traffic management. How to manage traffic in space, because a lot of, if small satellites, they grow in number in low Earth orbits, there could be problems, interferences. So how to take care of that? Like air traffic control, internationally, air traffic, there are rules and regulations. Okay. So space debris, today there is no law which is enforced. There are guidelines. These guidelines only take care of space debris. Okay. So first, reduce the debris generation. The most of the debris is generated in the early periods because of they used to leave the fuel at the end of the mission. These liquid propellants, when they come into contact, the fuel and oxidizer, the moment they come into contact, they explode. So these explosions were deliberate, and Russians more frequently were the culprits. Subsequently, more recently, there was a ISAC which destroyed a satellite and created a lot of debris. And debris has another phenomena. Debris creates more debris, even without, you don't add, because one hit another, it breaks up further. There is an evolution. In Vikram Sarabhai Space Center, they developed a software to predict, how debris will grow, even if you don't add even single debris through, more satellites. So this is a matter of concern, because even a small particle having that speed, the kind of momentum and weight put together, multiplied by each other, and then when hit, the kind of force, impulse will be very high and it can destroy. I have actually seen solar panels carried in space station, some of the European missions, holes punched, just particles have punched holes through the solar panels, many such holes, because it is in a low Earth orbit and this debris which is there created such problems. So debris is a concern. Now various methods, there are guidelines to control it. Don't generate as much as possible. You cannot avoid creating debris. At the end of life, you have to leave the spacecraft. So in geostationary orbit, they have put a condition. You have to have some fuel to lift it up to another 300 kilometers or come down by 300 kilometers. Don't keep in the same geostationary orbit, so that chances of hitting a operational good satellite is there. So reduce that. So there are many techniques relating to that, and at the end of it, you don't have both fuel and oxidizer. You went out fuel and keep one so that there is no explosion, avoid explosion. So like those measures we are also following. We are also part of, India is part of what is called International IADC, International Agency for Debris Coordination or something. Many space agencies are part of it. So, one thing which is being experimented but still it is in a very early stage is the active debris removal, scavenging, going and removing debris from space and bringing back. Very costly. It costs more to bring it back than to send it up. So nobody is going to do that. But technologies are being developed. There are some efforts in Europe and elsewhere. Then of course another concern is how to prevent arms race. Unfortunately, here there is no progress. Under Security Council, there is a organization conference on disarmament. There is no, just they are raising technical objections and so on, but no substantial progress to stop militarization of outer space. There is some concern, but everybody keeping some common interest. So far very drastic things have not happened, but we don't know whether such things will be so in future. Okay, so and lastly, exploiting resources through outer space. Luxembourg, US have already brought in legislations, national legislations for their country people, these provisions, and many people feel that this is going beyond the outer space treaty, which says that there should not be any appropriation of any part of space, and their argument is, if you don't allow private companies, if they don't have incentive, why they will put money into this? So this we have to see what will happen, how different countries will react, and what will be the international regime. So this is about the law part of it. Now I think floor is open for interaction for a few minutes.
Yeah.
I want to address your questions rather than the subject. Here, anything you can ask.
Part relating to the topic, sir, but it's about habit from my 10th class, sir. I have asked many of my professors also. I have not got a clear answer. So my question is, sir, we know the Earth revolves around the Sun due to gravitational force.
Yes.
And same as the Moon does around the Earth.
Yes.
So, but if you take satellites, they revolve around this due to gravitational force. But we are not saying that the satellite spins, but we say that Earth spins around its own axis.
Yeah,
So
so
for
satellites you can also spin, or you can also control in all the three axes, because satellite is an artificial object controlled by men on ground, so you can make it either spin or stabilize.
Yes, sir.
In all three axes.
So, but what is the reason the Earth rotates, spins around its own axis? Like for any object to spin around its own axis, it requires torque.
Or what is Newton's first law?
And then
An object, see, this is a kind of balance, the forces, when they are balancing, it is a stable condition. I keep a weight on this table. The table exerts opposite force, so it is stable. The force which is the weight of the object and the reaction of the table, they are equal and opposite, it is stable. If there is an imbalance, suppose the table is going down, crumbling, it is not able to react, what happens? So this balance has happened to start with, and it is continuing, and there is no force which is changing.
very heavy object, this is the problem, very heavy object, like a big meteorite or part of an asteroid comes and hits Earth, then there could be danger. You know, this spinning may change, axis may change, okay, speed may change, all these things can happen. Right now, a body continues to be in motion unless it is disturbed by this motion is a spinning motion as well as a rotation around the body. All the forces are balancing, that by physics we can easily demonstrate, and so the earth is stable while spinning and rotating.
How did it initiate, sir?
Initiate, you see, when it is not normally explosion is the beginning, all the material of various sizes, it is a dust and the particles, the bigger objects, all this. These things, if you have seen the clouds, all the particles have one inherent tendency to come together. So in universe also, it happens that all this dust, it could be hot matter, it cools down and this dust comes together, and due to gravitational forces when they are coming, and when they are coming closer, this force comes and there will be a kind of spinning motion. So because of the spinning motion you have the round shape, and then it will attract other particles, so it evolves like that naturally. This is the way it happens.
Guys, it's kind of really running out of time. Maybe we'll take the break to set up the next presentation, so sir will answer. So you can still keep answering this, but we'll start setting up the next presentation.
So it's not actually a question, but I just want your thought on it. So it was you told about the competition between the Russians and the USA. So it was actually, there is a clause like USA never landed on moon. The Apollo mission was a fake, just to bankrupt Russia.
That argument, many people they have examined it, but I think it is not.
Then one more question is that after, if we take the Apollo mission was a real one, why humans never went to moon again?
Because it is very expensive, risky, expensive. Public opinion, Vietnam War started, and at that time the public were very hostile to spending too much money by American government on. They started questioning what is the use. Okay, somebody has landed, second time they land. What people are getting out of that? That was the question, and the government felt that okay, there is no value of repeating that mission. That's why there was a.
So they also say the darker side of the moon has not been explored.
Yes, correct.
So what is the reason for that?
No, darker side of the moon, it is not correct to say that it was not explored. We don't see it from Earth, yes. But there are some spacecraft, very few although, what you say is correct when you see the number of missions. But there are now some missions which are landing of Chinese probe, lunar probe will be on the darker side of moon. So there some people are going and exploring that.
Given that ISS is an international project, why is there such a non-uniform representation of the astronauts? Don't you think, according to law, don't you think there should be astronauts from a diverse number of countries?
They are, inviting. Of course, the country which sends astronauts, they have to train, they have to spend some money, and opportunities are not too many. So somewhere it needs to be distributed. But I think by and large, people of different nationalities have visited ISS, and people have spent enormous money into ISS. So the countries which spent money, they should have more representation.
And why is India not yet a contributor to the ISS?
we felt that the kind of money you put into it, the benefit you get back is, see, there was a time India was interested. They said that, you cannot participate in design. You should only, send experiment. India was not interested in playing a second fiddle and, having a secondary role. That was the reason. Subsequently, they were interested. They were asking because money crunch came. They said they somehow hoodwinked Brazil to spend a lot of money, but most of the contracts went to Americans. Then Brazil also, started declining. So India saw all this and said that okay, it's not on terms which India would like to do. That is.
And with the advent of Gaganyaan, what would you say is the most ideal strategy for a 20-year-old Indian who wants to become an astronaut?
No, okay. Astronauts, there will be opportunity and competition, training, selection, all this.
Yeah, it's a very turbulent field.
Turbulent field, but it's not something which was not done. So certainly, and many Indians are also ready. They are fit to go and do such adventures. That is possible. And today's systems are also more safety oriented. So the thing is, for India, being a latecomer into this thing, how it can do differently, how it can derive better benefits of creating new industries, getting more jobs for people. It has to think in a different way and spend less money on this. And have a long-term program. It is always easy to do one-time thing. See, one problem with our planetary exploration or human program will be one time we may do, and subsequently what? Many times I interacted with Rakesh Sharma. He says, "What is this?" After he went, nobody went again into space. So many decades have passed. So he has such a bad feeling that you say, "What is this?" So many young people could have gone further. But anyway, it was the choice of India not to spend too much money on that. Now they are thinking, time has come. Probably what is needed is how to make this a win-win program to create new industries, create more jobs. At least if they can create some 2,000 to 5,000 jobs, new jobs, it's worthwhile. Young people can get opportunities. So India has to think differently and make it a long term.
Regarding the space debris, you said that there are millions of space debris in the lower orbit. So during a launch, how do they avoid the space debris?
The space debris is continuously tracked by some systems, the American system, NORAD system and so on, which have large number of stations and keep tracking and generating the debris situation. This is called space situation awareness. And based on the information exchange, cooperation that is there, if there is a possibility of a clash of a launching object and a debris coming very closer, then you adjust the launch time slightly and then launch. That is being done now. Yeah.
You said the moon treaty was actually accepted by all the countries.
Not all the countries. Some countries signed and some countries, less number of countries ratified. India has signed, but big countries like America, Russia, they have all not signed.
No, but the thing is, most of them signed in the 1980s. How did UNC get that permission to go to moon at that time?
No, going to moon even today, whether you are signing a treaty or not, because space activities can be participated by any country. That freedom is there. Outer Space Treaty allows you to go into space and explore. That is possible. But Moon Treaty, some special arrangements relating to exploring resources on Moon.
But however, they took some samples and
Samples are allowed. Taking samples are allowed, no problem. As long as it does not adversely affect the environment. Taking a few kgs of sample, It's no problem. So you can see the samples brought by the astronauts in physical research laboratory in Ahmedabad. And some laboratories it is distributed in India. You can see lunar samples.
Thank you very much, sir, for such a wonderful talk on the college. As sir said, we would know half there, we will think it is something, but here we got to know what exactly is what, So, Sujat, can you?
So I should also compliment these youngsters who are doing human service to all the student community in particular. So let us give a big hand to them.
So these are the students from Oakridge International School. So we met them when they were in 11th, and we just got a call from their school telling that okay, we have few set of students who are very much interested in astrophysics now. They want to do internship, and we found you if you can help them. Then we met several times to understand what was their interest, and we understood what they are good at, and so that we can do something together. And then so we came up with a project, and they completely did it. So we guided, and then we also launched it successfully with the help of Indian Institute of Astrophysics. So they're gonna present what is their project all about and how did it go and everything. So I hand over to the team. Who's going to start?
Can we start?
Gautam?
Yeah.
You guys need mic.
Very nice. Very happy to see such good quality and very nice. One second.
Good evening. We are the team that did the studies of SSERD. Our title was investigating. Our project was based around investigating the vertical ozone profile over Bangalore. My name's Aman. That's Rahul. That's Govind. And Rinzik couldn't make it to this presentation because he was sick.
Right. So, what was the aim of the study? So, the aim of our study was to, as you can see, establish a vertical ozone profile until the tropopause over the city of Bangalore during April of 2018. So what this means is we decided that we wanted to look at how the ozone profile is over our home city up until the tropopause, which is the second layer of the atmosphere.
So why did we choose this project? So all of us are very passionate about doing research. We have quite a few projects in quite a few fields, and we love doing projects in science. They always pose very interesting challenges for us to solve, and they teach us a lot. So we wanted to do some project in them. We also found that this would be a great way to give back to our community. find some scientific using science, in fact, we show that data, environmental data for managers, and tell them what they can do to fix value, make value a little better for them. That's why we chose this.
The importance of the study. So in this case, so ozone is usually considered a gas that's beneficial, right? When people think about ozone, it's considered, oh, we need more ozone. But that's only in the stratosphere, right? You do not want to inhale ozone, and not many people know that because ozone can be quite toxic. Especially India being a country that has had a surge in fossil fuels due to rapid urbanization and development. There has been a significant increase in tropospheric ozone, but it has not been documented, and there has not been a substantial number of studies regarding the concentration of tropospheric and ground level ozone over Bangalore. So we felt that it was necessary to get this information out, to tell people that the concentration of tropospheric ozone over Bangalore is much more than what it should be, and that can be quite harmful to health.
So how do we go about doing this project? There are a lot of parts involved in making this project. So we go over a few of them, few important goals step by step. So we started with mentors.
So our first step was find mentors. So we started by we approached SSERD first, and they very helpfully mentored us through the entire project, and I don't think this project could have occurred without their help. And with their help and with the help of our school, we got in touch with IIA, Indian Institute of Astrophysics. And they helped out with a lot of the technical challenges that we faced. And they also assisted us with the launch, providing the location, and the balloons. They also helped us provide the structural interface, which we'll get into later.
So what we needed electronically to achieve this project, right? So we had an Arduino, simple Arduino microcontroller. Because it was basic, it was cheap, something we could do and get the job done fast. We didn't want to use something like a Raspberry Pi, more complicated, cost us more, and would take more time. So we just used simple Arduino. So we wanted to store the data and not transfer it back, because we need a license to transfer data back. So we used an SD card reader. SD card mount, and we just write to the SD card while it's traveling, while it's throughout its life duration. We used the Bluetooth module to test whether the system was fully functional before takeoff, because this box would be sealed before we launch it, and we don't know if all the components are functioning perfectly. So the Bluetooth is basically a diagnostic component. It's for us to diagnose that everything is fully functional before we let the balloon launch. Now the main sensors, the main components we use are a temperature sensor and a gas sensor. So the temperature sensor is a combined module which has a temperature sensor and a pressure component. Both these sensors are imported industrial sensors that work under the very, very severe conditions of the upper atmosphere. So this payload has to go through minus 80 degrees Celsius. So these components are very important that these components survive that temperature. Because if they don't survive that temperature, it basically corrupts the data, there won't be any data for us. So it's very, very important that these components were industrial components and they could survive that temperature. That was our main goal in looking at this problem. Connecting the electrical circuit was quite simple. It wasn't very complex stuff. We just used Arduino sheet and it was simple stuff. It's not very complex. Similarly, for software, we again went to the easiest solution we could find for every problem. So we just used Arduino's implementation of C. It's a slight variation of not very complicated thing. So and Python. So Python was more of a data analysis. How do you analyze large amounts of data? So Python is one of the best languages to do this with. So we had around 40,000 lines of data at the end of the project. Each line has 3 data points and all of them need to be analyzed. So how do you do that efficiently? So we use Python. And then all of these need to be plotted into something visual that people not so technical can understand. Again, we use Python to do this. And the Arduino language is just used to give simple commands that every given interval of time it will record the data from the sensors, convert the binary electrical value into digital value and write it to the SD. So it's a very simple version of the Arduino.
Okay, so this is our actual payload right here. So it's constructed using 3-inch thick styrofoam, which was very helpfully provided by IIA. And over here we have a smaller compartment, and another larger compartment. So we put our main sensors in the smaller compartment with a hole at the top and at the bottom for a constant airflow. It's also covered in cap tape, cotton tape, and duct tape to provide even more insulation and for some structural integrity. And we added this funnel on the top for increased airflow. We also had to separate these into the sensors and the main electrical components because these sensors were industrially qualified and we tested them at SKC Labs, an industrial manufacturer. But the electrical components, the power bank and the Arduino, are not meant for such extreme conditions, and as such we had to separate the components in order to keep those better insulated.
Okay. So for the accuracy of the results, how we ensure that the results are accurate? First off, we got the sensors from manufacturers who assured us that these sensors have been used in similar high altitude experiments and that they work perfectly. Secondly, to make sure that the sensors were accurate, we again, with the help of SSERD, we contacted SKC Labs, which is an industrial place with many chambers that they use for testing a multitude of things. And after talking to them, they let us use their temperature chamber and their ozone chamber to test our sensors. And so what we did was we spent 2 whole days over there putting our whole payload inside the chambers and then seeing whether the sensors recorded the same data values that we set on the chamber externally, right? And so while doing this, we actually went through quite a few challenges. One of them was SD card, right? We realized that a normal SD card wouldn't work since it's not meant for harsher conditions. A regular commercial SD card wouldn't work. So we had to buy an industrial SD card, which costs significantly more, but has a higher range of operating temperatures. Furthermore, the testing in the industrial labs was quite expensive, but with the help of SSERD, we were able to get this cost waived, and we were able to test our sensors in the labs for free. And the results of the testing were that our sensors were fairly accurate. We didn't have much of an inaccuracy, and it was around ±1 degree Celsius, which is fine for analysis.
Okay, so here's the launch. As you can see, there were 2 very large hydrogen balloons that were filled, and these 2 balloons are what carried our payload up into the sky. So we launched from an IAA site in Hoskote, and at around 2:15 a.m., which is why it's so dark in the video. And our payload flew for 250 kilometers for about 6 hours.
So the challenges we faced a lot of challenges with this project. My friend Aman covers you. So we go over the technical challenges we faced. So you were talking about how the SD card was not working in the testing conditions. Yeah, it wasn't working because of some problem created by trying to initialize an SD card, mount an SD card in such a low temperature. The system was not able to mount an SD card at such a low temperature, which was a big problem. So we had to work around that. Another big problem we faced was some of the components weren't documented well. Like the sensors we acquired, we imported, they were well documented. So the code that was available for the open source code on GitHub was generally wrong, and we had to fix the open source code we found, which can be very difficult without good documentation. And that created quite a bit of challenge for us to actually figure out how the sensor works correctly without actual documentation from the manufacturer themselves telling them what to do. We had to follow more electrical schematics to figure it out, then actual code documentation was quite challenging in different.
Some other challenges that we faced with regards to the launch itself. When we launched, we had 2 weather balloons with the payloads, but unfortunately, due to certain circumstances which we're not sure about, one of the balloons burst prematurely. Now, how the whole system was designed was that both the balloons would be cut off after 2.5 hours of flight time. But after we got the results, we figured out that one of the balloons had burst prematurely, slowing down the rate at which the payload was going up. Right? Another problem that we faced was that after around 1 hour 15 minutes, around that time, we lost track of the payload. So we lost contact with our payload. We had a radio transmitter in one of the payloads that we launched with, and that was connected to our chase car and to the home base in Hoskote. But due to some technical reasons, we lost contact with the payload. So we had no idea where the payload was after 1.5 hours. And all we did was, we had the pre-flight trajectory that we estimated using software, and we basically went by that, but we still had no idea where the payload was, right? And as we didn't have an altitude sensor, we had to derive the altitude using the data readings we had, and that posed a challenge in itself as well, because our data and the data that we received was quite mangled up. And the fact that
you had the pressure sensor, with the pressure sensor you can calibrate altitude.
You can make an altimeter of the pressure sensor.
Yeah. So finding out the altitude from the data itself was a challenge, and I'll explain that.
So as you mentioned here, the pressure sensor is what got corrupted during the premature bursting. So what happened is this payload was launched with another payload, which was a communication payload launched by IIA. So they don't let us handle that, but they launch a communications payload which lets us track where the balloon is and gives us some basic data like altitude. So that's why we did put an altitude sensor on this. Unfortunately, our pressure readings were all over the place. It didn't work properly. While our temperature and ozone sensor worked perfectly, the pressure sensor didn't work properly. We don't actually know what happened. Even the PhD students at IIA don't exactly know what happened and why this happened. This is the first time this happened in 35 launches, but there is no real, we don't have a real answer why this happened. But basically our pressure data was not usable. So that's why we derived the altitude from the pressure. But we used something else to derive the altitude. So how did we do that? We used a lot of statistics and a lot of mathematics to derive the data. So this is the initial possible graph we got from the ascent rate that IIA gave us. So that shows us how fast we are rising. And if you notice, somewhere around here is when the first balloon bursts, and the ascent rate drops very fast. But after this point, we didn't have the ascent rate. So, but using software and predictions, we were able to extrapolate this data, create an ascent rate graph for the entire flight duration, which is around 6.5 hours. So from this, what did we do? We used a lot more graphs. So this was the maximum possible altitude of 6.5 hours. That is taking the assumption that the balloon was rising for all 6 hours 30 minutes, which is obviously not true. But taking this assumption, this is the maximum possible altitude we can get, which is around 28 kilometers. So once that was done, we needed to create a similar descent rate graph to find at what point the balloon started descending. So we took the size of the parachute we have and its dimensions, and we were able to calculate how fast the balloon would descend. And we were able to plot that backwards. So once we plotted a descent rate graph for the last algorithm length, we were able to find the intersection of the two graphs, which was here. So this showed us how the graph would ascend and descend. Of course, this is an approximation because it's using only statistics and not a direct sensor. And that's why we have error bars for around 500 meters plus minus. So with the plus minus error bars, we get around 25.8 kilometers plus or minus 500 meters. So this is how we were able to calculate our altitude for the graph itself.
So after all of that, what did we actually find? Unfortunately, while I'd love to tell you the results, we're legally bound not to disclose any information. But what I can tell you is that what we found is that the ozone levels in Bangalore are a bit higher than what they should be. So Alan's going to tell you why that's that.
Just to clarify, the legally bound is because of when we are applying for publications, the journals don't allow us to disclose the results before it's been published. And as we are in the process of publishing our paper, we cannot disclose any results before the paper is officially published.
Are you sure about that?
Yes. You will be soon if you publish the results before.
Wait, what, this is your project, right?
Yes.
Yes.
You're sure that it's your project?
Yes.
Yeah, then
But I cannot tell you the results.
You are publishing it with a journal. You are.
Since the journal charges people to read the paper, if we disclose the results, we're taking that money that they could get and.
So you get sued for duplication, basically.
Okay.
You're legally bound not to publish any results.
Clarify the point that the journal gets paid for people to read and then clarify, because this doesn't make sense, because 90% of the almost 80% of the journals that you have are like open for public to do research and other stuff. Only few are bound like that, so if you clarify, it becomes easier for like us to correlate with legally.
They don't want you to have sent it to another journal or another
They
publication.
don't want us to disclose results before we have officially published. So we're not legal. We are like contractually bound to not tell you this.
Like they told you can't mention it to anyone. Like actually what sir is telling has a point, like not, is it like to another journal that you're not supposed to disclose, or to anyone? Even to the general public, you're not allowed to disclose results before publication. But this is like an SSERD's event, like they're your so-called mentors and sponsors. Like, do they know about it? Yes. They know the results?
They have read drafts of the research papers. So
Okay.
they know the results. But we're not allowed to disclose it to on any public forums. We're not allowed to disclose it.
Okay, so what does higher tropospheric ozone concentration result to? Higher tropospheric ozone concentration can lead to damage to vegetation and crops, and we found other studies where it was proved that if tropospheric and ground level ozone concentration is higher than the stipulated values, then it can decrease lung function and affect cardiovascular potential and cause more risks of asthma and other respiratory problems. Now to elaborate on what lung function is the amount, the volume of air you're about to exhale in every breath, right? So if there is a higher concentration of tropospheric ozone that you're inhaling or the amount of air you're able to inhale and exhale decreases, which leads to other respiratory problems and can be negative. And so overall, tropospheric ozone at lower altitudes can be harmful to humans, can be harmful to the ecology and in general.
So now when we talking about what is it? See, the breathing takes place on the surface of the ground.
Yes.
You are measuring ozone at fairly higher levels.
You're measuring.
So what is the kind of phenomena that happens? This ozone, which is resident in the troposphere in higher heights, does it descend down to a level that causes the problem, or what is the kind of dynamics of ozone?
So
see, you can as well measure on the ground level itself, and so that is more relevant for breathing issues.
So tropospheric ozone in general, as you said, if you inhale, it's harmful. But the creation of tropospheric ozone is by oxides of oxygen and nitrogen, right? And oxides of nitrogen and oxygen are created due to pollution. So a higher tropospheric ozone relates to the fact that there's more pollution in Bangalore. Because if there was not more pollution in Bangalore, there would not be higher tropospheric ozone, right? So not only is it harmful to inhale tropospheric ozone, it is also harmful that if more is present, you know that there's more pollution in Bangalore, because it's a direct relation between ozone and pollutants.
Like tropospheric ozone is a good indicator of pollution. It's much easier to measure ozone concentration and directly measure pollution concentration. So it's easy to measure this and use this as an indicator for pollution.
So please take that as one of the objectives. That should come as your finding. If there are benchmarks, you can compare them.
So yeah, all of this is in the paper, the results are second, but yeah.
Good. I think it's a very nice project.
So in terms of what we personally learned from the project, the huge learning experience for all of us. We learned a lot of new skills in physics, mathematics, applied physics, computer science, which we have never got at all. So personally, I'm a computer scientist. I love computer science and do a lot of things, and that's why I really focused on this project. But I also made sure that I learned a lot more in mathematics and statistics, in data analysis, and a lot about physics. We have used a lot of physics to do this? The way we had to act local temperature
Is this payload also recovered or recoverable?
This is the payload.
This is the payload that we know.
This is the payload box that we are mounting. So designing is choosing the substances required to insulate it, the kind of way to do that. There was a lot of physics and mathematics learning that I would never got across. So personally for me it was amazing learning.
And also that while doing the data analysis, so usually in like schools and other places you learn statistics, but you don't learn an application of statistics. You never use what you learn in school. But over here we actually had to sit down and think about how we can use what we learned to make sure that the results are valid and that it makes sense, right? And then in general as well, like just the fact that we had to contact a lot of actual organizations to make the project work, and that was on a quite a big scale. It was a unique learning experience.
So I personally had always been interested in physics, and I've been thinking about doing a major in physics for my higher education. And knowing that I'd be doing a lot of research projects, I took this on just to kind of get an idea of what that would like. And I absolutely loved it, getting to work with my friends and apply concepts that, from a subject I loved, in a practical manner, was something new to me, and it really solidified my career choice. So, yeah.
So now we can answer any questions that are directly relating to the results.
So, could you like skip back to the first few slides at back?
Which slide particularly?
Just keep going back. Just give me
Any other questions?
Questions? You guys?
So you want to say that like India is a country where you have surge in, so increase in use of fossil fuels.
So rapid increase in use of fossil fuels that hasn't been documented very well.
Okay.
So like in other countries, a large use of fossil fuels has been going on for quite a few years now. And a lot of studies documenting the effects of that. But in India it's happening very fast, lot faster than in other countries. And the rate of studies doesn't match with the rate of the increase in fossil fuels. Fossil fuel is expanded massively.
I think that should answer my question.
Everyone
They are running out of time, so that's why. So and then you also said that you tested it at SKC labs minus 40 degrees, right? And you also mentioned when you were presenting it that like it would have to encounter temperatures of minus 80 degrees.
But what happens is inside this box, it won't encounter more than minus 80 degrees.
Okay.
So again, I can't tell you the exact value of what the sensor got, but it got around
minus 25.
25 degrees.
Could I know why is that a 10 rupee note inside the box?
That's just for fun.
Oh, that's just for fun. Great. So minus 40 degrees, right? So next time you guys do a project, consider buying dry ice, which is way cheaper at 600 rupees for like 10 kgs rather than going to such a lab and testing. And like you could use the dry ice at, like you can put it wherever you want. You can yourself create a small chamber out of dry ice. It would work out way cheaper. You could have tested it way longer than you would have at SKC labs. And you could have like, the test would have been better at the end of the day.
So the problem with that is we need to control the exact temperature. With dry ice, there's no way to know what the exact temperature
Dry ice is minus 80 degrees exact when placed in a thermocol box. It will not change, I guarantee you.
I want to check the rate of change of temperature. Again, I can't show you the graph, but what we did with the chamber is we took it at every 10-degree interval and we check the rate of change. So how the rate of change of the temperature works was the rate of change of the sensor inside, and then found the uncertainty between them.
So you kept on changing the temperatures and then
because
not possible with dry ice.
Because while the payload is going up, the payload is not constant at one altitude level, right? The environment temperature keeps changing. So you want the rate of change at which the sensor documents the temperature to be very close to the rate of change of actual temperature in the
Basically, our problem was if the balloon is ascending too fast, it may not account for the actual temperature in the atmosphere, while it's because the rate of change is too slow.
that should answer it. And then electronic components. Last one question. Electronic components.
You can answer it later.
Okay.
They'll come back to you.
Shoot out.
Because they work for like 6 months. So we have this internship certificate. We
enjoying this.
I need to have fun. I have stayed
No, I didn't.
Thank you guys for coming so far. So we are at the end. I will just, a lot of people online are waiting for the World Space Week online competition winners announcement. So I call upon Gautam and Alka, who are the organizers for online competitions. Yeah, for online competitions. They have been working very hard, and also the social media team. Vishnu and Deepesh been helping them a lot as well. And then we're done after this, right? Mahesh, they have my trunks. No, it's here. The winners for the online competitions are here. For kids, Anagiri is the winner. These are old students also. And for cosplaying, Nalita Shreyas. And for cosplaying, Abhinaya. And I would like to go down. So this was the poster made. It dedicates the...
It basically justifies the theme of Space Unites the World.
World Space Week. Space Unites the World.
This is the quote.
Abhinaya.
This was written by Abhinaya.
So basically, all these winners get the chance to go to Sriharikota to experience the rocket launch. Like, that's the opportunity.